Good morning, sir.
Good morning. Can you hear me?
Yes, sir. Yes. So we'll start very soon, sir.
Yeah,
Once
no worries.
Dean R&D is going to join, so then we'll start.
No problem. Thank you.
So HOD is here only, sir.
Good morning, Professor.
Good
This is
morning.
Venkat Reddy.
Good morning, Dr. Reddy. How are you?
I'm doing good. How are you?
I'm doing well. Thank you so much.
Thank you.
Good morning, sir.
Good morning.
Good morning, Professor Vinayak.
Good morning. How are you?
Yeah, fine.
We'll start sir, the session.
Yeah. Welcome, sir, to NIT Warangal.
Thank you so much. Thank you very much. It's an absolute pleasure and honor to be here.
So very good morning to all of you. So we'll start the session. So I'm Raghuram Kadali, so assistant professor and coordinator of this GAN program. So on behalf of the National Institute of Technology Warangal and the Department of Civil Engineering, so I welcome you all for this inaugural session of this 5-day GAN course on the decision support priorities of the smart city projects. So we honored to have today's distinguished gathering guests like the international faculty and the faculty members and the participants. So I now welcoming the distinguished international faculty chief guest, Dr. Vinayak Dixit, Professor of the Transportation System in the School of Engineering and Environmental Engineering at the University of New South Wales, UNSW, Australia, and Dean Research and Development, Professor Siris Hari Sonavare, and Head of the Department Civil Engineering, Professor K. Venkat Reddy, and the faculty members and the dear participants. So once again, I welcome to this 5-day GAN program on the decision support and priorities of the smart city projects. So we'll have this GAN program. So basically the transportation infrastructure in the urban areas play a critical role for the socio-economic development, and successful of the any smart city projects or like any transportation related infrastructure projects. So it is corresponding to the featuring at the forecasting of the urban population, corresponding to the meeting of the demands, and optimally allocating of the funds what we have in general. So to meeting of all the demands, then we need to make a decision-making process to prioritize the some of the projects corresponding to the meeting of the socio-economic development of the goals, and as well as the meeting of the sustainability and the health and the resilience of the transport infrastructures. So with this objective, the GAN course is designed, and this course is covers of the introduction of the transportation models and the transportation infrastructure economic assessment and the transportation project evaluation and the externalities of the transportation, congestion pricing strategies, and the computed general equilibrium models in the hands-on session. So with that, I request Professor K. Venkat Reddy, Head of the Department of Civil Engineering, to give an overview of the department.
Yeah, good morning. Our today's distinguished guest, Professor Vinayak Dixit from University of New South Wales. Professor Siris Sonavane, Dean RNC, and coordinator of this program, Bhadradiri Raghuram Kadali. Good morning to all of you. And so as when come to our civil engineering department, this is one of the oldest department in the NIT system, the NIT Warangal. So we have the 49 faculty who are working right now in the department in the various fields. We have the one BTech program in the civil engineering specialization, along with we have 7 specialized PG programs in the field of transportation, water resources, environmental systems, geoinformatics, and geotechnical engineering, environmental engineering. So we have the also PhD program which can with all the specializations, and also we have the QAP center who are working professionals can work in these things. We also have a continuous internalization with the programs through this type of GAN programs, Spark projects, and we also have MOU with IIT Bangkok to carry out the various double degree programs in the PG. So we are starting with one program, and in future we are going with other different PG programs. So we have the faculty catering all the, you can say, working in the different research areas, especially the, as I mentioned in the today's the GAN program, it is smart cities. So most of the faculty related to transportation, geoinformatics, and environmental systems, water resources, they are working on the various aspects of these things through Spark and GAN projects. This is a brief about our civil engineering department. Once again, I will just to mention that about this GAN program is one of the apt right now for this smart city things, since India is now developing almost like 100 smart cities. They are in the different stages. So this type of program will give you all the policymakers or who are all the right now taking the tomorrow later, they will take the going as a different involving in the smart city projects. For them, all these people, it will be one of the insightful program. So they can able to come to know all around the world how this type of smart city projects are implemented. So with this, I welcome all the participants to this program, and I wish you best of wishes for the program participants to get good knowledge from this program. So thank you very much.
Thank you.
Thank you, sir, for sharing details about the department and various activities in the department. So before I invite today's chief guest, Professor Vinayak Dixit, so let me introduce about the Professor Vinayak Dixit. So Professor Vinayak Dixit is the Director of the Global Research and Innovations. He is the Professor of Transportation System in the School of Civil Engineering at the University of New South Wales, Australia. His research has focused on the developing and implanting new technologies into the transportation system, ranging from the connected autonomous vehicles, electrical vehicles, and the use of quantum technologies in the transportation system. He has worked extensively in the major global industry, as well as including of the different projects like Google, IAG, Ford, and the quantum computing with respect to the GoGate and the delivery. And these are some of the few projects. And these works have led into the embedding novel optimization techniques and the controlling of the algorithms and began implanted with respect to the different various activities of the research. And his research has been funded by the Australian Research Councils, United States of the National Science Foundation, as well as the agencies of the global, including Australia, US, Indonesia, and as well as India. So he has published more than 230 peer-reviewed papers and also 2 patents, one on the traffic signal optimizations and another one is the quantum enabled vehicle controls. His extensive in the AVs and the electrical vehicle has been recognized in the parliamentary inquiries that would inform legislations on the new vehicle technologies. So with that, the small introduction. So please join me welcoming of the Professor Vinayak Dixit, our chief guest today's inaugural function. So as well as the international faculty to address the gathering. Thank you, sir. And our
Thank you so much, Raghu. Thank you, Dr. Reddy. Thank you, Honorable Dean Research. It's an absolute pleasure to be here and an honor to be here. In fact, the chief guests are you all here today. So, I am, I, I'm quite excited about sharing some of my thoughts and ideas around how we are able to make rational decisions around transport infrastructure. So the main intent of this whole course is trying to understand that among the plethora of interventions that are available, including dynamic message signs, smart traffic signals, um, uh, and other smart technologies, either to improve efficiency, to improve safety, or to reduce emissions. How do you actually make robust investments that stack up so that we are able to uh, justify the expenditures we are making towards the long-term benefits of that city and the nation? So that's the whole purpose, the idea, and I would love for you all to be thinking in that frame, and feel free to challenge. The whole idea of any course is about learning, and there's as much learning for me as for you all, and unless we challenge ideas and uh, challenge the status quo, uh, the way to move forward always becomes hard. So very keen and very excited to interact in this space, and look forward to working with you all over the next 5 days. And I would also I would love to hear from any of the students, if possible, Raghu, and on your aspirations and what you all think about what you all would like out of these 5 days, as you all will be spending a significant amount of time as well with me. Feel free to put it in the chat, or and I am looking forward for this to be a very, very interactive session, an interactive program. Any questions, any thoughts? One question I had is what backgrounds do you all come from? Are you all from civil engineering, from planning? There's absolute silence. Civil engineering. Thanks, Monica. Thank you. Thank you, Vikas.
Transportation planning and
thank you, Manish. And how many of you have done modeling and simulation in the past? Road safety. Good. And we'll try to cover some of that work around road safety and doing economic assessment of that as well. Good. Thank you, Sharnaz. So how many of you have actually done any kind of modeling simulation with traffic and transport? Did work on MCS, okay. Mass compliment.
sir doing on aviation project.
Okay, Manish. So you're working on aviation projects. So are you looking at traffic impact assessment on the aviation side, or more around where they
Land side as well as both.
both? Okay. Excellent. Thanks, Devashi. Visam. Okay. So we'll try to do over the next few days, we'll try to do either WISM, AIMSN, but we'll definitely be doing more large scale impact assessment as well. Perfect. Thank you, Monica. Excellent. So feel free to kind of, it gets very boring if I'm the only one speaking. So let's make it as interactive as possible, and feel free to stop anytime you want, and let's have a conversation as we go forward. I'll hand it over to Raghu and the head of school for any closing remarks on this. Thank you.
Raghu, I think it is in a muted. Actually, yours, I think we could not listen.
Raghu, we can't hear. Oh, yeah.
Yes, thank you, sir. Thank you for sharing all the views on the GAN program. So I now request Professor Siri Sari Sonavare, Dean Research and Development, to address the gathering.
Yeah, good morning, everyone. First of all, I welcome Professor Dixit for this Gian program and all the participants. This is very important. Like in NIT Warangal, almost we have conducted more than 90 Gian programs and Spark workshops actually. Basically, it brings all the international exposure of the faculty. Like Professor Dixit has their expertise, and he has brings out that international experience of this program to NIT Warangal. So I'm really thankful to you, sir, and I welcome you again. As well as this is the program. It's been Professor Kadali and Professor CSR Prasad. Both of them have formalized it with Professor Dixit. It's very important, just not the smart solutions, but also how to other quality-wise to improve the quality. This aspect of decision support is very important for specifically in smart cities, sustainability, life quality life, and other economic growth. So I wish you all the success to all the participants and colleagues. Thank you very much for inviting me for this inauguration. Thank you.
Thank you, sir. So I heartfelt thank you to all the dignitaries and the chief guest of today's inaugural program. So head of the department and Dean R&D, and all participants as well as the students who are joined here. So with that, so we are closing this today's inaugural session. So now we'll start the sessions at the exactly 10 o'clock. The first session will begin, and the Professor Vinayak will take over the session at sharp 10 o'clock. So thank you, sir. Thank you for joining.
Yeah, thank you, Raghuram, and thank you, Professor Vinayak Dixit. And so it's nice to have you here for our GAN students. Thank you.
Thank you very much. Thank you.
For the emerging infrastructure will be taken over by the Professor Vinayak Dixit. So thank you, sir, for joining, and I hand over to you, sir.
Thank you. Thank you so much. So I'll just share my, this is not too bad. I'll just start sharing my Let's try to see if you can see my screen.
Yes, sir. Screen is visible.
All right, perfect. So stop me, get involved, and um, uh, at any time during the during the lecture today. So the um, first part of my lecture is about looking at transport economics and the need and its need for in the context of the emerging infrastructure in India, right? So I'll just give you a brief background about where we come from and all the projects we have done, and what'll be great is the reason why I'm doing it is not to kind of show off. It's more around trying to give you a context so that sorry, uh, so that I can give you can give a context uh, through which and a lens through which you can actually ask questions, right? Like, so you can ask questions about how did this happen, say in the US, given this project, how did you do this in Europe? What does this mean for India? Or given our context in India, do those assumptions actually make sense or not, right? So that's the reason why I'm kind of talking about it. The second thing is um, uh, uh, one expectation is that I'm going to provide you with one tool, and that is the tool that can be used, and the only tool that can be used for cost benefit analysis. And that's not the case. Modeling is um model. So a key thing about transport economics is you have to do a model. You have to do a representation of the system and then evaluate different scenarios, right? So the question that comes in is, which is the most appropriate method? And so you don't have all methods uh, are 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 right or wrong, but it depends on the kind of questions you're asking from it, and we'll try to go through those and come to an appreciation with that. Does that make sense? All right. So most of all the work we have done here at UNSW and our city has been around smart technology, smart accessibility, and smart planning. So technologies includes autonomous vehicles, right? So one question that keeps coming up is around ADAS, advanced driver assistance systems. What does that mean? Should there be policies around that? And what does that mean for safety? Are we spending enough money on that, or are we spending the money in the right way? Smart accessibility means um, uh, are we able to provide good access? So access comes through public transport, vehicles, cycling, walking, and more recently there's these advanced transit systems where you have these autonomous pods that go through, and that's something that might come up very soon. So we are having to actually evaluate that. Ropeways are another one. It's a way of accessibility. One might say that all right, it's been there for many decades, but it is a mode which is being considered currently in India. And the final one is planning. So how do you plan in real time and come to a solution? So this is our past and present projects. We have done projects globally, and across, again in different for different applications for tolling, like looking at whether or not tolls should be applied, emergency management and disasters. So when there are disasters, how do you get people out? There are these questions that happen all the time, even in the case of um, when you have stampedes. I think it was a couple of weeks ago I heard about that there was some stampedes in Haridwar. So they're all part of our solution space. So how do we actually evaluate that, right? Sorry. So this is all our pillars we have worked on. So I don't want to spend more time, but I want to talk about a couple of tools, right? So one tool for actually doing these assessments are driving simulators. So we have one of the largest driving simulator systems, which we work with to evaluate questions of safety, but also questions of business. So when you're driving around, you might see billboards, right? When you see billboards, how much should the advertisers pay for those billboards? It's an important question, because those billboards act as revenue streams for the government, right? So these are questions which need to be asked, and which are being actually, you need to find the right framework and modeling tool or an approach to actually do an assessment. It's an economic assessment. How much should we be renting those billboards so that the government or the asset holder can make the maximum revenue? Models. So we develop all these models. So we have pedestrian network models, which we have used. We have congestion pricing models. We have traffic assignment models. So that's basically what we have been. These are the labs which we have developed and worked on. Any questions so far, and anything you would like to kind of talk about? All right. Excellent. So the problem is I'm unable to see the chat or any comments. So every so often I might kind of shift to the chat just to see what's happening there. Right. So I'll start with the introduction. Right. So when we talk about a transport system or even a smart city, and particularly for smart city from a transportation perspective, you have three main areas. One is the supply side, the other is the demand side, and we are always asking about safety. Now the first question is, what is supply and what is demand? The supply is basically the infrastructure which you're using. It is the roads, the number of lanes, the bus, the metro, the rail, then the signals which are there on the road, the speed limits. All of that is the supply side. We call that the supply side is because that is what is the public supply asset on which we all are moving around. Not only we, but also the freight is moving around, right? Demand is how many people are going to move from one place to the other. Where do they want to travel to? These days, it's mostly work from home. I'm working from home today, so it's work from home, but also there are a lot of activities which we can't do from home. So we need to actually travel to work. And if the demand is quite high, how do we manage that? We manage that through congestion pricing, tolls, etc. But all of these interventions, right? All these interventions, like in congestion pricing, tolls, signal systems, ramp metering, variable speed limits, increasing the number of lanes, putting in a metro, putting in a rail, they're all expensive. And governments only have a fixed amount of budget. And with that fixed budget, they have to actually decide which one is going to be the most beneficial. Should I be increasing the signal, improving the signal system that's going to, or put signals where there are unsignalized intersections, increase the number of lanes, or should I be just going and putting congestion pricing? And on the other end, there is safety, and the safety is around countermeasures, right? Like, so should I be putting guardrails? Should I reduce the speed limit, or should I put rumble strips along the edge of the road? All of these are questions and require money to be put into the system. And it is about how do we prioritize? How do you think we're going to prioritize? How do we come up with that approach? Any thoughts?
Sir, it depends on the various scenarios. Just like we can take performance indicators, policy analysis. These are the things which we can use for the optimal resource allocation in the case of road safety.
Perfect. So you mentioned performance indicators and policy interventions. So now that's an important point, is around performance indicators. It's such a subtle, nuanced point you made, Rahul, around performance indicators, because depending on the performance indicators which we choose, right, we are going to we'll end up using a different framework of modeling or different framework of assessment, right? So if my performance indicator which we choose around safety is reducing the number of fatalities, right, then you have to do a cost based on value of statistical life, which we will talk about. So and the benefits are, of course, how much we will be reducing that by, and the cost is what will be the cost of the intervention. But in the safety sense also, you could have the total cost of accidents, which includes property damage, um, uh, injury costs, hospitalization, all of that, and then that ends up creating a different framework. And then if you think about it, there's going to be another division within the government which will say our performance indicators is increasing the throughput of vehicles or reducing the travel time of the vehicle. So they'll try to increase the speed, correct? So we are trying to manage and come to an agreement across these different performance indicators. And once that is agreed upon, then I think 60% of the battle is coming to an agreement across the different stakeholders on the performance indicators. Do you agree with me or not, Rahul?
Agrees.
Perfect. So, and I think that is where we want to be thinking about and questioning everything I talk about. Question: what if we use this? Then how should we go about it, right? And I can give you examples of across areas we have done. Monica, the question you had is how are the solutions found initially? Most of the solutions are found based on either policies. So if there is a policy around Vision Zero, so like I'll give you an example. There was a policy on Vision Zero in Scandinavia and here in Australia, New Zealand. So that would give you a policy vision around that we want to reduce accidents to zero. So that would then inform the solution space. So the solution space then becomes, we know that as for every kilometer or every 5 kilometers that increase after 50 kilometers an hour, it doubles the chances of actually being in a fatal accident, right? So you use that as your approach to then say that could be a solution. The second solution is that we are going to create streams which are dedicated. So there are different ways you'll have to come up with those initial solutions, and a lot of them are either informed by government or by the people of the city. Does that make sense, Monica? So it's going to be that one is a bit more. The initial solutions are a bit more adaptive, and they keep coming up. And when you might start with an initial solution set, but the final recommendation that comes out might be totally different from that. Perfect. Good. All right. Now, one of the words you're going to hear throughout this this course is the word externality, right? You can have positive externality and negative externality. Now, what is externality? Externality, by definition, is something that is external to the system, something that we had not considered, right? So, for instance, one of the you must have experienced this all the time and if any of you have been through Bangalore or Delhi or Bombay, you increase the number of lanes, the congestion increases, and it will increase in like 2 days, right? So, and that is because people are adaptive. There is a behavioral element to this. People are trying to minimize their travel time, or trying to make sure that they end up coming to a certain equilibrium. But that was never considered when we were trying to, in that initial state, when we were trying to increase the number of lanes so that we increase the throughput. We were just saying that, right, if we right now the congestion is the demand for this particular road is 4,000 vehicles an hour, but we only have a capacity for 2,000 vehicles per hour. So we'll double it, right? We'll double it to cater for that demand. But the moment we double it, the demand will increase to 6,000, and congestion has increased. So externality, in some sense, is the to your point, Raul, was around anything that is external to the performance indicators that were considered in our intervention. Make sense? So congestion, safety are all basically externalities, negative externalities of our emissions. They're all negative externalities of our whole transport system. We can so I'll give you another example, a policy example. After COVID or during COVID, there was an immense push here in Australia to kind of create cycling routes, right? So there was a push around cycling, and there were a lot of cycling lanes and cycling routes that were created here. Great initiative. It improved the mode share of cycling by almost 2, 3, 4, 5%. And the car owners, the people who drive, were calling it a negative externality. But the people who were using the cycling, for them, it was a positive experience. So the concept of externality needs to be thought of from a systems perspective. So whenever there's an externality, what that means is it was never considered as part of our system when we were making our initial decision. All right. So how do you analyze a system? And this is just a very, very standard book from 2000. There are multiple ways, right? Like you've done analysis around systems. One is making an actual system. You experiment with the actual system. So you go and make an intervention. So for instance, I know, like when my family members are driving, they say, oh, the traffic signal is so bad, we should change it to we should provide more green to our approach. And what that means is we have to actually go and increase the green by like 5 seconds. But if it does not work out, it will improve my travel time. But if it does not work out for the system and creates a choke point, it is a huge negative impact for the whole system. So it's a costly endeavor, right? So going and making small changes or big changes to the entire network, the actual system, is a very risky proposition with huge costs, right? So what people do is they try to experiment with the model. The model could be either a physical model, so you do all these physical models at scale, particularly in geotech, you do that in structures. The other one is mathematical models, where you end up doing simulations or analytical solutions. In transport, given that our infrastructure is huge, our systems are huge, we tend to use mathematical models, right? So we tend to use simulation. And the reason we use simulation and not analytical solutions is because, I'm sorry, I'm getting, any questions, Rao? Can you put yourself on mute? I can, thank you. The reason we can't get to an analytical solution is because they are very complex. The equations, the equations that come out, it's not easy to solve. You have to actually simulate it to come to a solution. And we'll talk about those properties, those fundamental properties that need to be there in our models. All right. Any questions so far? So this is just an example of how it looks like, right? So experiment with the actual system. You might end up with a gridlock, but you can have a physical model. where you're actually evaluating it. You really can't do a physical model with for traffic, but we did use a lot of physical models for autonomous vehicles. So when we were looking at autonomous vehicles, we used to use small vehicles which were looking at detection at scale. So we were reducing the scale and we were looking at detection, and so we were using physical models for autonomous vehicles. But then you can also move to digital twins and simulation models. Any questions? Any questions so far?
Sir, I have one question
Yes.
regarding this simulation. You are mentioning the simulation. So, which time we decided which type of simulation we have to? Means the strategic simulation. We know that when we built any city, for that time we're doing the strategic simulation, or any particular part of city we do this macro simulation for Vissim software. So how we can extract the data? Means I know that when I extracted the data, but how we can interpret to that part to our analysis?
Oh, very, very good question. And there's an entire lecture on it, but I'll start with it. It's a good question because then it'll prime your thinking when we talk about it later in the later during the week. So the way to think about this is there are three types of modeling approaches. Actually, four. I'll put it four. The first is micro simulation, right? Like micro simulation is about, the word micro means you're simulating every vehicle, every entity, every agent in your system, right? When is it useful? When it's useful is when you're trying to create interventions which rely on the interactions at that level. So think about interventions where that really matters. Let's think about some examples. One example is a traffic signal, right? A traffic signal, depending on if I have a merging, right? Like if I give a free, here it is, a free left turn. It's merging into the traffic. It's a free left turn. They're merging in, right? It creates, that merging creates bottlenecks. It creates congestion, right? So you need to be actually able to simulate the trajectories and the interaction of every vehicle and interaction between a pedestrian and a vehicle. And that's where micro simulation is really important.
Yes, got it.
Now, the second layer is something called a meso model. Meso model is, you're not worried about how they're interacting. I don't care so much about lane change, but I care about if I increase the number of lanes on NH, what will be the impact on the whole network dynamically? Will the congestion dissipate? And at what rate will it dissipate? At what rate will it form for the same demand? So it is telling you about the dynamics of it, right?
Yes.
So and whether or not it will affect the whole network. So it's a meso, but it's a dynamic. Then you have a third level, which is static. Now, a static network is basically the assumption that the main question you're asking is, are there going to be enough vehicles coming in, or if I put in a new road, what will be the patronage, rough patronage over a day or over a year? So you're looking at long-term forecasts. So you don't really care about what is happening on a daily basis, but you're looking at averages over a day or over a year, and that too 20 years from now.
Yes, sir.
And then you have the final one, which we will talk about a lot more. I think on the third or fourth day, I think it's is around the computable general equilibrium model, which is essentially looking at economics. So what is the impact of if I put in a big national highway or a big railway? What is the impact on the GDP? What is the impact on the prices of rice, or prices of what will be the jobs? How many jobs will be created? These are the questions which actually Niti Aayog is interested in.
Yes.
So if you think about who the decision makers are, the national government, the Niti Aayog, the Ministry of Roads, the Ministry of Railways are interested in those questions around the economic impacts. If I put a railway line, what will be the overall logistic cost? How will it impact the GDP? Then you have a strategic model, which is basically the state or the city, which is interested, okay, if I put a metro, what will be the impact? Will there be enough patronage 20 years from now?
Sorry, sir, I interrupt you. The strategic model, which stage they will come? Means the first, third, or last one?
Sorry?
Are you mentioning the strategic model, right?
The static model, so strategic static.
Yes. So this is come from third stage of modeling, right?
So when you say that, yeah, it's the third. So yeah, micro,
Yes,
meso, macro. Yeah.
Yes. Okay.
So we call it macro. So when I sorry, yeah, you're right. Strategic static models are called macro models, macroscopic models.
Okay.
And then you have meso models, which is basically the city transport. Like the city of Bombay uses a transport network model. So which is basically saying, all right, we have a special event, so let's go and make a one-way there, or not allow vehicles to come into this region. That is where you'll use that. And micro models are when it's the traffic engineers who are actually saying, okay, we should change the traffic signals here. Maybe we should increase the, we need to redesign the roads at that place, or redesign the reconfiguration of roads at a certain place.
Yes.
Make sense, Manish?
Yes, sir. Got it. Thank you.
Very good question. So Monica has asked a question about, can you describe the adaptability of AI model simulations compared to mathematical model simulations for infrastructure modeling? Because in AI modeling, we give the data for training. This can affect the policymaker. That's true. So there are a lot of, you have actually, Monica, the question is so beautifully put. There are several things which I want to draw your attention to in that. So the first piece is that in any AI modeling, the models are very data dependent, correct? So now, for instance, one question which is always asked of these AI models, or any of these transport models, is based on scenario analysis, scenarios which are not present right now. What if I put a high-speed rail from Mumbai to Delhi? Right? We don't have data on that. We don't have data on that. So what we need to do is rely on behavioral models and models which we understand and which we believe are immutable to implement there. But the AI models are really great for places where we have data day in and day out. And in fact, a great example which we use on a daily basis, right, is the Google Maps or Map My India, or which is basically you ask a question as a decision maker every day: which route should I take? I need to go from point A to point B. Which route should I take? It's actually based on AI because it's getting data, and the routes are all fixed, and the number of people, it has a sense of how many people are coming in, coming out, what is the travel time. So based on the travel times, it's able to predict into the future. It is able to give you the best route. It can also tell you when to leave, when not to leave. So there is a nuance there about trying to figure out where those AI models might be useful and where you might need to complement or supplement those AI models with other approaches. Does that make sense, Monica? But it is definitely a very interesting area of research, and a lot of people are actually working on that. And most of the AI-based models are looking at micro simulation. They're looking at micro simulations and trying to make it faster, because right now micro simulations are so computationally taxing that they end up taking a lot of time. So what they're trying to do is replace the choices of each entity with an AI-based model. if we see on record, it may happen that on paper, data is different as well as on infrastructure on site is different, which can affect the model. That's true. It is absolutely, there are issues with data. So it's, let me share an anecdote. One of the stalwarts, he just recently passed away, Professor Hani Mohammad. So Hani used to say this quite eloquently. The whole purpose of transport and infrastructure models is not to be able to predict the traffic, but to be used to prioritize projects. All right. When we are doing this large scale infrastructure, what is really important is, are we able to prioritize them consistently? So if there is a project which is important, it always shows up as being important. Then the second one is second important. Third one is third important. Now, fundamentally, there is a saying which was done by, I think, by Savage. All models are wrong and some models are useful. And we need to focus on what, and to make these models useful, we need to be very clear about what its use is. So if the use is to actually prioritize infrastructure projects or prioritize projects, and to make sure that at least when we are saying that this is 1, 2, 3, 4, they always show up as 1, 2, 3, 4. That is the key piece of what we are trying to achieve in a lot of these infrastructure models. And when it comes to predictability, we need to be able to show that if this happens, then this would have happened. Like, let's say there's a merging section, and if you reduce the merging section, there's going to be more congestion. If you increase the merging section, then traffic will merge more smoothly and will reduce the congestion. So these are the fundamental, I would say, physics of traffic streams, or the fundamental realities of traffic, the physics of traffic, which we try to incorporate, and the fundamental economics of transport demand and behavior, fundamentals of behavior that we try to incorporate. And we say that those are the truths, the immutable truths, and which we will use to ensure that we are prioritizing the road infrastructure. Perfect. So yeah, absolutely. And I think AI has a lot to offer.
Sir,
Yeah.
regarding to that point, I have one question.
Yes.
I belong to Maharashtra. In
All right.
Maharashtra, there will be a lot of agency will be working under the government, Miss MMRD, MSRTC, all
Yes.
such.
Are you
So,
from Bombay?
Yes, from Mumbai. Yes, Thane. So actually, sir, my main concern is when we are generating or creating any model for XYZ authority, we know the another authority what is the planning is going on. When we decided this is our merging point, when we go to the site, we realize that the another agency tried to start their flyover in that point. So there will be lot of effect on economy as well as the means the infrastructure. Means रोड बनते जा रहे लेकिन ट्रैफिक कंजेशन का कुछ सॉल्यूशन ही नहीं मिल रहा. So actually
तो मैं इसका एक I'll give you an example of this. So
yes,
मेरा पहला project जो था इंडिया में, it was Haji Ali. It was
yes,
Haji
sir.
Ali.
Yes.
So it was my first project in India, and you know the sea link, it comes into Haji Ali, and it comes directly into Haji Ali, and it hits
Okay.
it
That
at
cover lift.
yeah,
Is,
it hits it at an angle.
okay.
Now this was 2000. It's many years ago now, so probably 16 years ago, 2009. So it came, and the whole idea was to actually reduce the travel time. Fantastic project. But the problem is it comes and hits this link, right? It hits this link. And the congestion there was because it used to come and there was a traffic signal there, and it used to hit that. And because of the traffic signal, there was no impact on travel time. The queues were all the way back.
Yes.
And the congestion was crazy.
Mm.
So we were struggling. We were struggling to get the government to actually recognize and understand. So that time there was the Thane Municipal Commissioner, Shri Asim Gupta. Yeah, that he absolutely visionary bureaucrat. Uh, we said so. We went to him and said, look, you can actually be using traffic simulation. If you look at the US, Europe, we have been using it for like 10 years, right? So we have been using it since 2000. And he's like, okay, let's try to do this. So through that, we actually came up with the solution of the roundabout. So you take a left, you take a roundabout. We came up with a lot of solutions.
Mhm.
The only one that could actually fit, given the cost, the environmental impact assessment, the right of way, was that you take a left, take a roundabout, and come back. Now, to your question, that was the first project, and it was the idea that we needed to use simulation to just solve that problem. But then slowly it became that the bigger issues were actually at the interfaces. Like you pointed, you make a model of a certain, you make a model for Thane, but the moment you finish the Thane model, the main problem is at the where the model finishes.
Yes.
You know,
Got it.
so that's how we then ended up developing the idea of a citywide model. Like you have to develop citywide models, and because you want to be actually uh, capturing the boundary conditions appropriately. You want the boundary conditions of your models to be not uh, to be independent. Like basically, they need to be at free flow speeds, so that whatever you're finding here, finding within your system, is not affecting the boundary conditions. And that's the whole idea um, of coming up with a citywide model.
Yes.
So, and then the question always then the question came. The state government came and said, look, should we be investing here in Bombay versus Nagpur versus Nashik? And that's when we ended up developing macro models, statewide models for state economic development. And then it became a national model. So I think you're again, it goes back to that original point. It is every model goes to the question that's being asked of it, and who are the decision makers. So if the state is asking a question, you might not want to be developing a national model. You want to develop a state model because they are trying to make an assessment between Nagpur, Nashik, Bombay. Yeah.
Yes, sir. Got it.
Okay.
Sir, one more question I have. Actually, I
Sure.
do the economic analysis for National Highway Solapur to Tempurni in past years ago. That time we see means in Tempurni to Solapur there will be 4-lane roads, National Highway. There will and similar road will be constructed Delhi, Surat, Delhi National Highway.
Surat, Delhi. Yes.
Yes, they are both are parallel to each other. So when we do the economic analysis, we see the lot of traffic that we considering during this Tempurni to Solapur road, they are shifted to that expressway. But that road will be proposed after the DPR we have submitted means before first for we submitted the Tempurni to Solapur DPR. After 2 years, the National Highway Authority proposed this road expressway. So the main concern is, so we can first of all predict one thing, how we can economic or how we can produce more trips and road revenue from particular road. But after a certain point we realize that there will be another road be proposed parallel to that road, so all the traffic will be shifted to that road. So how we can predict the economy means that scenario means दो road side में बन रहे तो how
I understand. So the thing about it is always those are issues which happen globally. So I think the Solapur to Tembur link was proposed by the state, correct? Or was it proposed by
no, sir, no, NH. Both roads are proposed by NH.
proposed by NH? All right. So it must have been different groups of NH within NH. So the only thing you can do. So there's this concept of in any models or any across like mathematics, economics, physics. There's this concept called ceteris paribus. Ceteris paribus means all things equal. So you really can't anticipate the kind of disruptions that might happen. The disruptions could be such a proposal is made and it affects the DPR that was put forth while not knowing that approach is going to happen. So the best thing that the government should be doing now is actually evaluating those two, that whether it really makes sense, right? Which one makes sense? Just because it came first doesn't mean that it should go ahead, right? But there must have been a parallel DPR that might have been happening without the other group knowing, and one of them got decided to be done. And so that problem happens all the time, everywhere. Those things you can't predict. But given everything, now that you know that this new route is coming, you have to actually evaluate with which one actually makes sense.
Okay, sir.
And if you have already started, if the investment has already been made on both, then you have to try to figure out how you can make best use of the second national highway. Because I would imagine that the traffic on Sholapur Tembur might be going in a different direction also. There might be a different user class. So of course, when before the Surat Delhi piece was there, a lot of the vehicles which were going from Delhi to Surat might have been using that one. But after that, after the Delhi Surat comes in, there might be other logistics modes that might be using. So I think that a lot of traffic from Nashik, which becomes a logistic hub, can be using the Sholapur one, right?
Yes, sir. Right.
So there might be other ways that those links can be used, and we'll talk about that. We'll talk about a few of those examples as well.
Yes, sir. Thank you.
Perfect. Thank you. All right, we'll move ahead. So the learning objectives of this course is to basically understand the core concept of transport economics, frame India's transport systems through efficiency, equity, and sustainability lens. So I think if we look at a lot of the DPRs, right, going back to your point, Manish, is a lot of the DPRs are focused on improvement in productivity, reduction in travel time savings, improvement in safety. But very rarely they consider its impact on fairness and equity. And there are some really good examples actually in India under the current government as well as in the previous governments as well, where there have been roads that have been developed, which might not have made a cost benefit analysis from a traditional, because we were only looking at travel time savings at that time, might not have made sense, right? They were connecting the rural areas to cities, and there was not much traffic that was going there. But what it really does is it creates economic development. And that is where the idea of fairness and equity comes in. So can we actually, and that is what actually put forth in the Dixit Bharat 2047 vision, as well as in the transport projects that are being proposed, is the idea of building out fairness and equity. And then the question comes, how do we actually evaluate that? How do we include that? So going back to that, the idea which Rohit was mentioning, Rahul was mentioning, was around performance indicators. How do we create performance indicators around safe, equity, and fairness, and sustainability. So we will talk about that. We will diagnose constraints around congestion, logistics costs, safety, connectivity gaps, and articulate why and where emerging infrastructure is needed. Apply numerical cost-benefit analysis as well. I think there are people more qualified than me to discuss why and where, but when I say what the why and where, I'm not going to tell you about why and where, where we should be, but I will provide you tools. That this course will try to provide you tools about articulating the why and where, right? So it could be based on safety, it could be based on connectivity gaps, it could be based on fairness, it could be based on efficiency. Now, so what is transport economics? So again, the idea of transport economics is that goods are scarce, so the resources are scarce, and you need to allocate it efficiently across your network. How do you do it? So you need to identify your demand, you need to identify the type of demand. Is it people? Is it freight? Need to understand the cost structures associated to those. And what are the regulatory frameworks, the pricing, the investment? Where are you going to get the money for building new roads or building new infrastructure? Is it going to be from tax? Is it going to be from bonds? Is it going to be through PPPs or hybrid annuity models? All of these are important questions. And why does it matter? It matters because it informs modal choice, network design, and improves welfare via efficient pricing and investment. Any questions? All right. So the scale of the transport, all of you know this. We have one of the largest national highways probably after the US, and we are probably building 40 kilometers, lane kilometers of road every day. That's the rate at which we are building. So we are building at a rapid pace. We are the largest rail network globally. We have 12 major ports, 200 minor ports, 100 plus operational airports, and those airports are increasing. So what we are trying to do is we are increasing our connectivity through all modes at a rapid pace. And the question that then comes to Niti Aayog and the Prime Minister's office is, given the limited resources, given the limited financial resources and the private funds available, where should we be investing that? Right? Where should we be investing that? Should it be airports, ports, roads, rail? And if we are investing in the ports, how should we leverage that by providing appropriate connectivity? There's no point having a port without appropriate connectivity to the rest of India or the rest of the region, right? So if there are investments being made, how do you leverage those investments to take it to the next level? That is a question. And so the usage pattern matters, right? So one of the things which we always find is that between road and rail, almost 97%, 96 to 97% of the freight movements and people movements happen on road and rail. The rest, I mean, air traffic for people is quite high, almost comparable to the rail, but depends on, like, I'm talking about intercity, right? Like comparable to rail. Roads are cheaper, but when it comes to freight, which is an important part of our economic growth, it is air and shipping are pretty low. And urban mobility is creating pressures, and it's creating pressures on the logistics costs as well. And finally, there is an institutional complexity, right? You have multiple ministries, you have multiple states, and you have public-private partnerships and multilateral partners as well, like World Bank, ADB, who are funding and trying to. So there's a lot of complexities across the regulatory frameworks. So going back to the core, so we have, when there are all these different stakeholders who are vying to put in a certain infrastructure, or we need to have a common language that we all agree on, to say that this is based on this is what we are going to actually make decisions. And that's why we have, under the Gati Shakti program in India, we have the network planning group. It's called the NPG. Yeah. So it has secretaries from all the major groups, from all the major ministries, who are making a decision on which infrastructure makes sense. And that generalized cost includes monetary cost, value of time, reliability, and other externalities. So those externalities include safety, emissions, and environmental impact assessments, etc. So that's the generalized cost. And this is one of the places where those performance indicators we need to decide on that. What all needs to go there? Is it value of time, logistics cost, monetary cost, reliability, externalities? Some of them end up becoming constraints. So some of the constraints are that you need a EIA done. So that's an environmental impact assessment done and agreed upon from the forestry department, from other departments, so that once you get clearance from them, then only you can talk about other aspects of it. Yeah. Elasticity. So elasticity is price divided by time. So elasticity differs by purpose, income, and availability of alternatives. And we'll discuss that in length. So elasticity tells you that for a small change, what will be the impact? If there's a small change in travel time, if it reduces, what will be the increase in demand? It makes a difference. If the elasticities are high, that means a small change has huge benefits. And economies of scale and density, right? So that basically talks about even more network level macro characteristics around connectivity. Any questions?
Sir, how we can interlink that HDM model to all these things?
So yeah, so good question again. So HDM model is a life cycle assessment. So it goes into the cost. So it goes into the cost of your infrastructure, right? So let's say we are building 40 kilometers of road daily. What is the cost? The cost is not the capital cost of actually building it, but the cost is the life cycle cost of that, right? What will be the maintenance and operational cost of that over the 25-year life period of that, right? So what is the point of having roads which we are not able to maintain and keep up for the next 25 years for the life? And that is where I think some of the PPP models actually help solve that problem, right? Because those PPP models ensure that the responsibility that these the concessionaires, the people who are actually building those roads, have the incentives of ensuring that they maintain the roads to the right quality.
Okay.
So the HDM model goes into the cost piece of the cost benefit analysis. The benefit piece comes in the economic assessment, the safety assessment, etc.
Yes. Got it.
So so I'll give you so for the rest of the class, HDM model is a model which is basically developed by World Bank. I think it was originally developed by World Bank. I forget, it's called the highway. What is the, Manish, can you remember the full form for HDM? It's highway development model. Or so essentially what it is, the HDM model is, it's a life cycle cost analysis model. So what it does is, if you have a road asset, it says that it starts depreciating in value Like it needs more maintenance, and after 5 years, 10 years, so the cost increases, but you discount it. So there's a discounting aspect around it. So that's the way of actually calculating the cost. Okay. Any other questions? Hopefully, I know there are a lot of terminologies, new terminologies. So please feel free to put in the comments if there are any questions around on the questions that are being asked. Any questions? All right. So what are the trade-offs and externalities, right? So the trade-offs are basically capacity versus induced demands. So what that means is if I increase the capacity, there's going to be more demand. So you're trying to trade off between that. You're trying to trade off between speed and safety. So efficiency and safety, which we talked about. The cost and service quality. So if you're trying to make your transport system more affordable, you try to keep the cost down so that people can access it. But then the service quality reduces, right? So how do you ensure that there's high service quality while keeping the cost affordable? So affordability is a big piece of this whole trade-offs which we are trying to make. Externalities includes congestion, crashes. We've talked about that. And you might have positive spillovers. So we have talked about negative externalities, which is congestion, crashes, emissions, noise, and land take. So what land take means is basically the land gets taken over, but basically the right of way around it. But the positive externalities include agglomeration. So what is agglomeration? Agglomeration means that you end up creating high density locations sometimes. High density means that more people might be walking. And agglomeration also supports higher economic productivity, because what people do is that they will try to get their raw materials from closer by. So if there is a sugarcane factory, there will be if there's a sugarcane fields, there will be a sugar factory close by. Next to the sugar factory, there'll be a biochar plant or a biogas or a biofuel plant. So, and it really improves market access as well. So there are different policy tools apart from the connectivity. There are a lot of policy tools that come into place. Like you have fuel taxes and fuel excise, congestion pricing, parking policy, emission standards. So one of the biggest current dilemmas which a lot of governments globally are facing is around fuel tax. Why is that? Why do you think? Sorry. Why do you all think that the fuel taxes are a big point of contention?
Sir, actually, I read one paper on the fuel subsidies. Uh, Sir, I came through that paper. Removing the fuel subsidies improved the road safety. So it is of great concern that government cuts the fuel taxes.
So I'm not able to fully understand the concept immediately, Rahul. But like I think the thesis is that if you're providing fuel subsidies, there will be improvement in safety.
No, sir.
Okay.
No, sir. I'm saying that if we remove the fuel subsidies, then the road safety improved. Sir,
So removing of road subsidies improves. Makes sense, right? So if you remove road subsidies, the cost of actually using the road increases. And if that cost increases, there'll be less people using the road. So that might be improved road safety. In fact, there's another. So that's a really great point. But why are fuel taxes? Yeah, like fuel excise. Why is that a point which governments are very concerned about?
I am not talking about the road subsidies. I was talking about the fuel subsidies, sir.
Fuel subsidies. So again, same thing. The fuel subsidies will increase the cost, right, Rahul? So it will
Yes.
increase the cost of travel. So that the moment the cost of travel increases, because of the elasticity, the less number of people will travel. So the AADT will reduce because of that. So there is some relationship which makes sense there, but I would love to read that paper. So yeah, please share that if it's possible.
Okay, okay, okay.
Yeah. But so that's an interesting point. It's what you talked about was the relationship between fuel excise and uh, and safety. But let's think about fuel excise. Why is fuel excise important for the government? Why do we have fuel excise? The reason why we have fuel excise is because the fuel excise is the revenue from the fuel excise goes into maintaining and rehabilitating road assets, right? So every time you go and fill in your petrol or diesel, you're giving a percentage to the government so that the government can then use it to maintain, re-asphalt the road, improve the roads, um, build new roads. So that's what it's being used for, the fuel excise. All right. Now, what is happening to the fuel mix of vehicles right now? You have more number of electric vehicles, right? The number of electric vehicles are slowly increasing. If the number of electric vehicles are increasing, the revenue from fuel excise is going to reduce. Yes or no? Yep. So the
Yes.
moment that reduces, the government has less funds to actually invest into rehabilitation of the roads. And that is where the governments are currently struggling and trying to figure out policy changes around that. How should we deal with electric vehicles? So there were all these policies to create subsidies for electric vehicle uptakes. Now, a lot of governments globally are thinking of actually creating an electricity excise for vehicles, where based on per kilometer usage and all of that, you're going to pay a certain amount. Because every time you're running, every kilometer you're running, there's a wear and tear you're actually creating on the road network. And that's what you're paying for. Does that make sense?
Yes.
So this piece of the policy tool around fuel taxes and fuel excise are going to become a very, very critical point of contention and a point of innovation, which will happen in the next 5 to 10 years. So this just gives an illustrative modal split. You can actually pick that up from Statista as well. It's fairly. So now I'm going to go into a bit of a contextualization around the different rationales for um, different rationales for the different projects at a national level, right? So the focus of the Bharatmala project was creating economic corridors and uh, that can actually create connectivity across borders and coasts and integrate into the logistic park integrate the logistic park. That was the main focus of this. And the economic logic behind this was reduce the generalized cost, which is basically it's referred to as reducing the logistics cost. And by the way you reduce that is by bypassing urban bottlenecks and improving access to new markets and supporting new markets. So that is the economic logic, right? And then you have to do it. So what are the economic outcomes, expected outcomes? Travel time gains, reliability gains, lower logistics costs, and safety improvements. I will actually provide a small example which we have put together for uh, the dedicated freight corridor, and I'll share that with you. Uh, Just give me 1 second, please. 1 second. Hello, can you hear me? Sorry.
Yes, sir.
Yeah, okay, perfect. Thanks. Yes, Monica, that's what, sorry. So I missed your message. Yes, exactly. Right now, we are trying to provide subsidies to electric vehicles for basically, there are two main reasons. One is for cleaner, for creating cleaner, cleaner vehicles. The second one is to create more energy resiliency and energy independence, right? So the more, because right now we import a lot of fuel. So those are the two main reasons. But eventually, we will get to a point where every vehicle, if it becomes like, even if 40% or 30% of vehicles become electric vehicles, then the pressure on the government in terms of actually getting revenue to fund uh, um, fund uh, rehabilitation of projects, rehabilitation of roads becomes a problem. So how do we go about that? And we don't have a solution, but right now some countries are looking at it as a possible of doing mileage-based taxes. And there might be other ways, and so it's an open problem. And we hope that you can come up with a cool solution. So yeah. So going back to sorry. So that's the Bharatmala, and it's important to kind of actually understand the vision and understand what the purpose is, and that will then inform your performance indicators, which you're kind of looking into the performance indicators, which you're going to be looking into in the modeling framework. Similarly, for the dedicated freight corridor, it was all about segregating the freight and the passenger flow, right? The problem has been that the freight gets stuck because of shared modalities. So how can we actually create long haul, fast moving, decongested trunks of railway infrastructure? Similarly, for the Sagarmala inland waterways, a lot of these have been always based around freight, if you look at it. Udan and regional connectivity has been actually about people. And it is about actually creating mobility of people fast and cheap. So we will talk a lot about the financing models as well over the next few weeks, next few days, sorry. And this just gives you an initial idea of how different ways we fund new projects. We generally fund it through public budgets, which is basically through taxes, and the second one is VPP, where we are getting private partners to actually pay so that we can use the public budget for other activities. Hybrid annuity model. So it's about after the PPPs, the hybrid annuity model, asset recycling, multilateral loans. All of this is around where the risks sit, the risk of the demand sits, and how the payments are then managed towards that risk. But we have an entire session devoted to this. But I want you to just start thinking about, when we are looking at new infrastructure, we're trying to figure out how we're going to fund it. And if it is a private investor, they are going to look at how am I going to make money? And that's where the PPPs come in. So it's all about revenue generation. So you need to be, your traffic models and traffic performance indicators are all based on revenue. When it is public budget, it's all about public good. So it's all based on what will be the impact on the GDP as a nation. Which sections of the society is it supporting? Is it helping kind of creating access to sections and populations which were not accessible before? Is it going to drive employability and employment opportunities in those regions? So those are the questions which help. So we'll go through a numerical example later this afternoon. All right, so we'll go through that at length and this thing. So I think we've talked a lot about the technology innovations and equity. So yeah, with that I'll stop and see if you've got any questions, and happy to have further discussions.
So please, if any questions are there, so then it is good to discuss.
No, sir.
So far, are you all motivated enough? Is any of what we discussed today new, or has provided a different perspective?
Yes, sir.
Sir, is there any study happened related to the compared to risk analysis respect to the financial models? Okay, if you are going to adopt, this is the HMA model, or like this is the kind of BOT or TOT model, and this is the kind of risk expected to the investor.
So before every project, there always is like any PPP project, there is, and at the DPR stage, there is a risk assessment undertaken, and then a lot of it ends up becoming a negotiation. There was, I think it was Frederick. There's a paper, very interesting paper on optimism bias and around infrastructure projects. So what happened in 2000s here in Australia was there were a lot of projects and tunnels that were built based on PPPs. And several of them actually ended up becoming bankrupt because the modeling was done not appropriately. There was a optimism bias in the number of people wanting to, when the forecasts were made, there was a lot of optimism bias there. So in terms of the forecast, and it was driven by the bureaucracy because they wanted the projects to happen and all of that. And there's always going to be a money. You almost at some point, people who have been working in the field, if you are a consultant who's working on a DPR, there's always going to be pressures on you from the client to demonstrate that this project is feasible. All right. Please be careful. Please be careful on that, because a lot of the companies, like actually AECOM, had to end up being liable, and I think it was almost criminal liability for almost $250 million because they made inappropriate modeling assumptions to support the project. And that happened 15, 20 years later. So whenever you're doing this DPR, be careful. And so that was, when we talk about optimism bias, that was one place where it was found to be problematic. But otherwise, there are a whole bunch of studies that have undertaken, which have kind of looked at risk analysis. I can't remember. It has been a while since I've looked at that literature. But I can come back to you.
Okay, sir.
Any other questions? Thanks.
Any questions from anyone, participants? If there are no questions, then we'll end up the session now. So then the next session will begin at 11:30. So instead of 11:45. So I will start the session, next session, second one. Thank you, sir.
Thank you, Raghu. Thank you very much.
Thank you, sir.
Thank you.
Yeah, welcome back for the second session. So basically this session is going to make understanding about the what actually the smart cities projects, specifically for the Indian context. To begin that, so we are going to understand that what smart city and what are the different types of the components are involved, and what is the role for the transportation in that, actually what is the strategies for the funding of the smart cities, and generally are basically what economic evaluations of the transportation projects means. So these are the contents we are going to cover in this lecture. So let's start with that. So there are different definitions as given. So for the smart city, so there is no standard definitions for the smart city in general. So, but if you look at that, the cities having the varies in terms of the corresponding to the country, in terms of the demographic or in terms of their behavioral aspects of the people and the willingness to change the reforms respected to the strategies and the resources we are going to adopt corresponding to the aspirations or the interest of the public. So this definition will get changes generally. But what actually it makes the smart city, it is the kind of basic infrastructure, and the infrastructure should be as smart as. So that means the infrastructure will take the data or take the considerations of the data, will give the solution to make the infrastructure better way for the public who are living into that particular area or the surroundings of the public. So in general, it is very basic thing actually, how you make the infrastructure more smarter and smarter by using or adopting of the different systems into the condition. So that means the services provided to the users or the public in the cities or like the city or general in the urban areas, mostly the data to be driven from the public side, and based on the data, the solution to be given to the again to the public, and the public will be relying on the development or improvement of the service provider by the agencies. So that makes the city smart generally. So as we discussed that, so there are different components that generally it is relevant to the smart environment and the smart economy, smart transportation, smart governance, and the smart living systems and the smart people. So mostly if you connect each and every component, so this component will be having the smart enough in the data collection system in general. So this data makes the public are more and more comfortable in their livability of a city. out of which we are going to generally focusing on the smart transportation. So why the need of the smart transport, smart city generally in Indian context? If you look at that, so there is an increasing of the drastic increasing of the population. So in the urban area, so which is driving corresponding to the increasing of the demands respective to the different need of the people in the city. So this need may be relevant to the water or like the kind of severages or maybe like the kind of electricity or maybe like the demand for the transport or like mobility, out of which the mobility is one of the dominant parameter or component, which is more and more people demanding respected to the increasing growth of the city populations in general. So it is expected that the 42 cities with the populations in excess of the 1 million, so maybe it is going to be beyond 50 cities or maybe like the even 60 by the 2040 or 2050 around. So as per their expectations, it is so by almost by 2030, so almost 40 to 50 cities will be going beyond the 1 million population. At the same time, it is also expecting that by 2030, 60 million people are going to live in the cities, which means that by 2050, around the 50% of people are going to live in the urban area as compared to the rural areas. So that means there is a more and more attraction of the people towards to the urban area, which is more and more urbanizations going to be happens. This increasing of the population in the urbanizations might increasing the demand towards to the different aspects like the infrastructure, electricity, water, gas, all the components. So all this leading to the deteriorating the quality of the life generally. So it is expected that so the deterioration has to be handled by means of the smart way generally. So that means the whatever the expected demand for each and every component in the city relevant to the water, electricity and all. So to how we are going to address it actually. So that's the reason. So the Indian government has promoted 100 smart city missions was launched on 25th of the June 2015 actually. So that means they are going to address with respect to these 100 cities of the scarcity of these of the some of the components, that is the water supply, electricity, sanitation, efficient of urban mobility, IT connectivity, governance systems, and the safety, health, each and every component. Basically, it is funding or like the corresponding to the MOUD collaborations with respect to the state government from the central to the state, which makes that there is a kind of the fund allocation for the financing system between the central and state. So what are the need of the developing of the smart city in the future? So what we are trying to understand mostly in terms of the e-service systems, or maybe like the multimodal intelligent transportation system for the transportation point of view, or the public safety, or the energy conservations in terms of more sustainable energy systems. So then emerging disaster management systems and the smart housing systems. These are all the components will combinations of these components will be going to make the city more and more smarter. So this smart city will be going to address the several problems. So that means suppose if I'm taking a small examples, so with respect to the how we are going to address the sanitation problem, so like how we are going to collect the systems and how we are going to dispose the system, how you are going to enough to select a routing system without any kind of disturbance of the general public. So this makes that okay, this system has to be adopted to some kind of the RFID tag system for the bin collections, and these bins once it is filled, these RFIDs will give information to the collecting agencies, and these agencies will be select those bins corresponding to the truck routing system, and these truck routes might be optimized to collect all the collection of the bins and disposal at the some place. So this is the way generally the each and every components work. So now if I'm taking the transportation point of view, so each and every junction might be having the n number of vehicles. So the volumes and the queue lengths at the volumes and corresponding to that optimized signal timings, and these signal times will be synchronized from the one junction to the other junctions to make more and more optimized way of the signalized junction operation. So these are the way generally the smart city technological or the basic infrastructure will be required. So then the question will come whether I need to go the projects related to the sewerage or like the kind of the water or the energy or the mobility, which is the highest demand will be there, or the highest priorities to be given. So there is a way to understand corresponding to the demand respective to the city side, And based on these demands, the governing system will be identifying which project to be implemented first compared to the one or the other. So now if you talk about the smart transportation alone, so it is about the generally the urban planning systems and the designing and the management of the operational system. Then finally we are expecting outcome from this operational and the management system. So it is all about the integrated development of the spatial planning and this again the transportation traffic strategies and the respect to the environmental and public safety. So then there is kind of the technological inbuilt are corresponding to this kind of the improvement of the strategies like the automation of the system or the real-time informations and the advanced control methods. At the same time, there is a kind of smart sensing and the computing. So that is the stationary and the mobile data and the urban informatics and the data collection system. So that will be equally communicate and mutually understanding together that makes the more integrated urban mobility or urban multimodal transportation system with respect to the high density of the cities like the mostly like the metro or mega cities. So that makes that there is a change of the travel behavior because you are going to provide a data-driven technology to the users. So based on this, users will identify that which route to be selected or which mode to be selected on which time, and corresponding to that, which are the kind of the roads are available respective to the free flow or like the at least a kind of the minimum delay occurring on the routes, and the corresponding to that again, so there is a chances of that the user will going to change sometimes from their personalized modes to the public transportation modes. So that makes that there is a more and more smart travel behavior of the city are corresponding to the public. So then finally the smart performance, that is an efficient way of understanding of the demands of the particular city and understanding the resilient and the reliable of the structure or like infrastructure and the safety of the infrastructure. And finally we are trying to promote in terms of the green as well as sustainable transport. So that is the one of the final outcome what we are expecting by means of the smart transportation in general. So there are different types for the city planning system we have. So we have the high density development to corresponding to addressing of this high density development. There is a rapid or corresponding to the rapid urbanations. So then we are trying to enabling of the technologies and the urban infrastructure, which is enhancing the sustainability, accessibility, mobility, and the well-being of the public. So these are the some of the kind of smart way of understanding of the smart transportation. So like the adaptive signal control system, which understanding that our entire network of the city is completely communicated each other and integrated each other, and network level optimizations of the corresponding to the like the traffic or corresponding to the signal timings of the each and every junction. So then we have the shared mobility system, making them to understand the public what is the on-demand driven shared mobility system for the each and every categories of the modes available in the cities. Then we have the shared bicycle system, so that makes more and more access to the public transportation and within the shorter distance of the trips in general. So that makes the public are more and more well-being and happiest in the or like the livability of the public in the urban area might increases. So then how we are going to look at the technologies improvement or the urban infrastructure point of view, like how the autonomous vehicles modify the fundamental traffic flow properties or conditions, and how it is going to impact the infrastructure to be identified, to be understood. And again, the how electrical vehicle interfaces with respect to the smart grid and corresponding to the energy distributions or the demand for the energy distributions and the storage systems, and corresponding to that how the environmental impact is going to be changes generally. So then again there are different types of the sensing system. We generally adopt it in the smart way of the collecting of the data. And if you are trying to look at that, what are the sensing system will be required generally to collect the data, because always it is very important to understand that what kind of the data is important for us and how this data to be used for the different purposes to make the more and more smart way of understanding, or maybe like the adopting of the system or corresponding to the adopted system, how this data will be useful finally. So that's the reason what are the competing strategies and the centralized systems and the distributions of the data system processing and the sharing of the disseminations of the informations and the storage of the information are very, very important to make more and more sustainable way of operations of the city in the smarter way. Because if you are connecting as a city with respect to the several sensing operation system like the Wi-Fi, cellular signals, and the smartphones and the CCTV camera, you will get the huge amount of the data. It is all important that how you are going to handle this data and how you are going to effectively utilize the data to make the usable to the public point of view, or how you are making this data will be useful for the different means of the strategies even. Let's understand the smart travel behavior corresponding to that. So what are the data-driven technologies we have seen with respect to the Wi-Fi, cellular signal, or like the smartphones? So it can be easily understandable how people are actually moving in a city, or how people are actually moving from the one zone to the other zone, and what time of the day they are making the trips, and what kind of the modes generally adopting. And corresponding to that, we can easily understand what is the demand for the different types of the modes in the particular given city. Then how we are going to connect these demands respective to the different modes. Then how we can make as a kind of multimodal traffic or the information system to the public is available, or to the available to the public, and what kind of the future technological driven system for the city, and how the electrical vehicle implementation can be taken up. And also it is to be understand that corresponding to this smart travel behavior or the smart traffic data collection system, then how we are going to adopt to optimize the signal timings. So to make the robust traffic control systems and the activities and the mobility patterns to be understand, then what is the average vehicle kilometer travel is going to change. So there are several aspects relevant to the change corresponding to the smart travel behavior in general. So that's the way actually we have the user apps mostly. So that means whatever you are trying to understand the data driven techniques, so that is mostly corresponding to the user apps. Mostly if you look at that, in some of the cities you might be having the specific apps relevant to the transportation system, and these apps will get the huge amount of the data corresponding to that, what time of the day they are making the trip, and where they're actually going, and what is the cost of the trip, and how much amount of the trip length is there, and what is the trip frequencies respective to this using of this app. So then the hurdle will be generally most of the time these data cannot be shared by the stakeholders or in between the stakeholders, or if the data is collected by the government and this data cannot be given to any kind of the policymakers or like kind of other researchers in general. So then we need to have the linking of this data corresponding to the different organizations. Then sometimes we need to have the open source of the data system of the developments. Then we need to have the system integrations among them. Then we need to identify this data to be used for the citizen purpose again. Or else, whatever we are expecting with respect to the smart city, it cannot be fulfilled completely until unless this data is openly available for the users as well as for the general the strategy developers or like the policy making decision makers in general. Now, if you look at that, one of the project from the Amaravati side, so then they have implemented so several cameras, CCTV cameras to collect the huge amount of the data. Then they made the almost a 17-kilometer NMT infrastructure for the docking stations, or maybe like kind of the storing of their vehicles in terms of the bicycles. So then they also started the public bicycle sharing system. So then they also made some kind of the provisions for the signages as well as the kind of the roadside infrastructure improvements respective to the understanding of the what is the queue lengths are there at the junctions even. So there are several kind of amenities they have provided for the infrastructure implementation or like improvement process. So then this infrastructure makes that the city is more and more smarter way to collect the data, and this collected data again will be useful to fundamentally to make some strategies again. So this is the way generally the most of the city under the plan of the 100 smart cities, they're collecting the information or collecting the data to make them cities in terms of the public point of view, how the city can be smart. So then in that, so the urban planning is also makes the more impact in that actually. So that means how the city, the growth is there, so to be identified. So then we need to make them the land allocation pockets for the different purposes. Then how you're uniformly allocating the land pockets for the different purposes. So then we have the different types of these systems in terms of the kind of given for the commercial purpose or like the recreational purpose, how we are going to allocate a different land for the different purposes and the residential and these the land allocation process or the land use planning process will also makes that how we are going to collect the proper information corresponding to the each and every land use. Because if you know properly identified the land use allocation plans, then corresponding to that what are the data we generally collecting, so this data will be beneficial for the different plan purpose. Let us assume like if you have planned a proper city in terms of this is the specific zone of the residential and you have the specific zone of the commercial or like the kind of the recreational activity, then we know that how the travel has changed at the different day of the times as well as the different days even corresponding to the weekday versus the weekends. Then we can also get to know that what is the kind of the travel behavior respective to the using of the mode and the using of the routes between these two zones. Like that we can acquire the different kind of the means of the data between corresponding to the land use allocation plans even. So then if you look at that, so then we need to address that corresponding to that what are the kind of the parking spaces are available in the city and what is the kind of the lack in terms of the parking spaces or the lack in terms of the public transportation operational like frequencies and what is the demand towards to the private vehicles and what are the kind of the inefficiency for the last mile or first mile improvement or the inefficiency for the public service deliverabilities and the safety and security to be identified. So then all this makes that what kind of the driven technology to be implemented for each and every condition at the locations. So then if you look at this is the kind of the lack of parking spaces to the lack of traffic disciplines will be the smart commuting system to be addressed in the city. So now if you have the inefficient public service deliverability or like the safety security, then it is maybe going to this the municipal smart municipal operations or the governing systems of the city. So then we have to connect all the components together. So then you will have the connectivity of the all components that makes that okay where we have lag and what need to be identified for this to address this lag are kind of the deficiency of the system in terms of infrastructure. Then what kind of the driven technology to be adopted in that. So this driven technology will make that it is more and smarter. So then the smart city what we are actually have the strategy or the planning that can be achievable. So then we have the smart commuting respective to corresponding to the different kind of uh, components which are involved into the smart city. So like if you are taking the smart parking, so we need to apply the smart parking metering systems. Mostly that may makes that if anybody entering into the city centers probably might given that how many number of parking locations are available. So mostly if you look at that the upcoming cities like the gift city or like Amravati, so these cities are adopting such kind of the smart parking technology, so which may give the users automatically how many number of parking spaces are available in the city center. The intelligent traffic control and the traffic violation system will give the understanding about that what is the kind of signal waiting time at each and every selected junction corresponding to the selected route or the maybe like what are the route you are actually traveling. So then we have the integrated transit management system that how we are going to integrate multimodal transport system between the transit buses versus the metro or maybe like the paratransit versus the bus. Like there are different kind of the activities are involved into the TV. Like apart from that, we have the city Wi-Fi system and the smart poles like corresponding to the grid operations for the respective to the electrical vehicles. Then we have the GIS mapping, then we have the different app systems for the collecting of the data. Then we have the integrated command control centers with respect to the collecting of the informations and the integrating of the informations and the service provided to the users respective to this integrated informations again. So then why we need to have the localized smart infrastructure generally? So because the smart city solutions cannot be simply the transplanted from the one geographic to the other geography. What are the solutions we are providing the cities like maybe like Mumbai or Pune or the maybe Baroda. So it cannot be directly transferred to the other cities, even if it is having the same geography in terms of the land use area, or maybe like in terms of the total amount of the population, even because it is all depends on that how the acceptability of the this infrastructure by the public is there. That maybe changes corresponding to the city to city. So again, the context, culture, economic activity of the city makes more impact. Then the city should consider the urban problems holistically. So corresponding to the urban problems, we need to have adopting of the technology. Then this technology is going to address that problem. It does not mean that what are the identified solutions of the one city will be directly transferred to the other cities. So then we have the different policy instrument for the promoting of the localizations of the smart infrastructure. So that is the local innovation systems. That means maybe like integrating of the different policy makers, or maybe like the different entrepreneurs, or like the local universities or the research centers together to address the different challenges required for the that particular city. And also promoting of the open data is one of the important challenge generally. And also the global open data initiatives by the governments and the private sectors have been great impulse with respect to the smart city applications in general, and establishing of the urban innovation units. And that makes that more and more benefits whatever the data we have collected corresponding to the smart applications or the means of driven technology systems in general. So this makes that okay, there are different types of the policy instruments to be taken care or taken out. So then we have the different types of the finance and the well developed business models we have corresponding to that. So like if you have any questions, we'll pause here. So then we'll try to address if you have any kind of the points to be discussed. Hello, I hope somebody are there online or listening.
Yes, sir.
Yeah, any questions from Manish or anyone?
No, sir.
Any other? So okay, then we'll continue. So because if any project, if because even if you look at that, there are different components involved into the smart city project generally. So related to the specifically even the transport infrastructure implemented projects, like we have the, let us assume there is a kind of project, the implementation of the bicycle facility or bicycle infrastructure. So then there is another project, maybe like optimizing of, or maybe like providing a signalized coordinated system in a corridor, selected corridor. So if there are two projects in your hand, so now the question will come, which project has to be funded first, or which project to be identified is important. So there is a kind of way to understand the strategic way. Okay, this project, if you are implementing, so these are the kind of benefits we are getting. So if you are implementing the coordinated signal system, these are the kind of the benefits. So most probably we will always try to understand that what is the socio-economic development of any specific project, and corresponding to the socio-economic development of the project, corresponding to the user's point of view, what are the kind of the total amount of the cost can be incurred into the project. So then we'll balance with that. So apart from that, so there is a kind of the political driven, also the priority system will be there most probably. So apart from that, sometimes we need to go the sustainable way of the projects are high priority compared to the other categories of the project. Because if I'm comparing the coordinated signals versus the bicycle transport infrastructure, so the bicycle infrastructure, transport infrastructure is the dominated in terms of the sustainability compared to the signalized coordinate system. Even though the signalized coordination system may be expecting that there is a kind of the reduction of the delay, then there is a kind of overall benefits to the users. Again, there is a overall benefits in terms of the environmental damage can be controlled, but still we have some kind of idea whatever the development or whatever the development you are going to take up, compared to that development, what kind of the outcome or the benefits we are getting directly actually. Because the coordinate signal, even if you are done, there is a kind of the fuel consumption, there is a kind of increasing of the vehicle kilometer travel. There are several aspects that are involved into that. Yes, somebody asking question. How these models can be prepared in waste management. So mostly for the solid waste management point of view, like if you look at the routing technology, the routing optimization systems, so there are several projects they have already driven into the this kind of the solid waste management point of view. There are several cities actually adopted that automatic data collection system of the bins. Suppose if these bins are actually filled completely, so then there is a kind of the RFID tag system are there. So based on the RFID tag system, so then it will be given the message to the agency who are actually collecting of the bins. So then once they have started the collecting, because sometimes it is giving the optimized route for this kind of the solid waste management point of view, because the agency will get to know that which are the routes are available, because if it is already congested route and if you are transporting a kind of solid waste management along that route, it is again problem to the users generally who are actually traveling on the route. So most probably even sometimes the distance travel by these trucks are little higher, then there is no issue on that even actually, but still they are trying to optimize as much as possible in the entire route network system. Okay, corresponding to your origin point of the collection system and corresponding to the disposal point of your destination, what is the optimized route corresponding to the less number of vehicles. So that's the way generally they will start optimizing of the solid waste management data collection. Sorry, the collecting vehicles, generally the disposal vehicles will call.
Sir, I have one doubt. In your slide, you are mentioning you are collecting the data from the sensors, right? So, which type of sensor we generally use? Means on-road detector type, on-crossing detector type, or another type? Can you
So there are several ways of there are several types of the sensors we have. When we are talking about the sensors alone, so sometimes some of the cities they adopted the vehicle to infrastructure related sensors, which means that the roadside sensors, okay, which are collecting the information related to what are the number of vehicles are passing on this particular route. So it is all depends on that actually. So there are different types of the sensors are corresponding to the connected vehicle. Suppose the city has the connected vehicle system, so then these connected vehicle system will be emerging, or maybe like the sending the different types of the informations from the one vehicle to the other vehicles, and these vehicles again interact with respect to the roadside sensors. So then these sensor again will be going to send the information to the central control unit, then how many number of vehicles are actually playing on the different routes. So these sensors may be like the Wi-Fi, that is the 5G based Wi-Fi sensor systems, which are embedded on the roadsides, which is again embedded into the your vehicles even actually. Suppose if I'm taking a kind of the autonomous vehicle, so then if you observe the autonomous vehicles or even connected vehicles some extent, then you have huge different types of the sensors embedded into the vehicles, and these vehicles will give or emit the different types of the information section. So there are sensors are there at the roadsides, there are sensors are the inbuilt into the vehicles, and there are some kind of the system which can be enabled to collect the data by means of the smartphone applications. Like if I'm using a kind of mass mobility as a service, so then this mobility as a service, then it may give the huge amount of the information how people are actually moving from the origin to the destinations, and what are the modes they have accessed it, and what time of the day they're actually traveling, and how many people are actually traveling from the one origin to the different zones corresponding to their destination choices even. And apart from that, we have the sensors or maybe like kind of the traffic detectors, like the embedded into the payments. Most probably, like if you look at the adaptive traffic control system, which is done the project in the Kochi or even the Pune. So there is a embedded detector systems for the vehicles actually. So there is a kind of the detecting of the vehicles in terms of the traffic flow, as well as the speed of the vehicles, as well as the travel times of the vehicles from the specific corridors. So based on this traffic flow, speed, as well as the travel time, they're trying to optimize the signal timings.
For this sensor, we also detect the pedestrian. For
Yeah,
pedestrian, yeah, yes, please.
there are specific cameras we have actually to detect the pedestrian, but it is countries like in India, it is very hard to get some of the kind of categories of the people when they're actually mixing with respect to the some kind of the vehicles like the two-wheelers or maybe like the auto rickshaw, because most of the time, so there are some kind of the weighing motion type of the sensor system we have for the pedestrians. Apart from that, we have the automatic the camera for the detection system of the pedestrians are also there. So these sensors or the weighing motion system generally works well in the developed countries compared to the developing countries, because there are several issues with that actually. Because the cameras, if you corresponding to the angle of the camera, sometimes these pedestrians are mixed or maybe like the traveling along with the two-wheeler or like auto rickshaw cannot be detected directly or that easily. But we have those different types of the cameras or like the weighing motion sensors are there respective to the pedestrians.
Yes, sir, got it. Thank you.
Yeah, any questions? We'll move forward. So the smart infrastructure project require the pooling of the public and private resources through creative financing models generally. So that is generally we call as the PPP models. So then there are different types of the policies or the taxation system and the regulatory certain corresponding to the data what actually we are collecting with that. So then these taxations and the regulatory or the tax regulatory policies will be makes that there is a kind of innovative method of kind of financing or the corresponding to your project mostly. So mostly the government trying to address there are several issues with respect to the collecting of the system of this data as well as the putting a financial model with that data actually. So then that's the reason. So there is a kind of innovative thought process or the idea to be important for the increasingly making a strategic way of the investment of a project, because you are collecting the data. Suppose let us assume in a smart city, so there are some cities they adopted even smart watering system or the smart even gas or the electricity actually. So then there are some kind of the thought process on that if you are implementing a smart electricity application, so then you are curtailing of all the kind of the unexpected the electricity consumption of a particular house. Then if you are increasing that corresponding to the increasing of the meter level of this any specific smart city house, so then you are collecting the more fees. So then there is a chances that the people will be disobey or the people are not ready to adopt such kind of the system. But though it is mandatory to have such kind of the system or the smart way of the collecting of the your smart electricity or the even the watering and all, it all depends on that how the people are the kind of the urban in the urban areas, how people are accepting such kind of the systems are very important, because you are collecting each and every data of these people in the urban areas. So sometimes the people disobey any kind of the willingness to pay. So then it is again difficult to the collecting of the tax policies or tax regulations respective to that system. So strategically, the funding of the smart city infrastructure and technological investment is the critical to the relations of the smart cities. And the smart city projects are often complex undertaking and involving of the public and in terms of the multiple stakeholders and corresponding to the risk involved to the stakeholders are very, very complex, because we don't know what is the risk involved directly to the each stakeholders. Sometimes there is a combinations of the stakeholders need to be worked together. Then that what are the fund we are actually pulled out from the public need to be shared with respect to the stakeholders. Again, if you have such kind of the financial models, again it is very, very difficult. So then the citizens must be made aware of the cost involved into that and the associated benefits respective to the prices what actually they're paying, and corresponding to that payment what is the kind of benefit they're expecting. And it is also important that what is the kind of the commencements or the kind of the projects before to be paid or after the project to be paid. So these are the some of the issues generally occurs respected to the smart city projects. So then we have the technological driven innovative financing models. So this maybe it is the kind of the how efficiently we are gaining the different resources corresponding to the gained resources, what are the kind of appropriate technology or monetized benefits we are getting, and corresponding to the benefits what actually we need to ask them to public to pay, and that what the public actually paying, that maybe makes the smart infrastructure investment constant. But you have kept as the more and more driven technologies, so then corresponding to that payment what we are acquiring from the public might not be balanced. So there is a huge unbalance. So sometimes there is a viability of the project, or sometimes it is not viable of the project even. So that's the reason. So sometimes what are the public-private partnership of the investment or the financing models we are taking, so there is a more complex will be there, because we are having the huge amount of the data, and handling of the data with respect to the different stakeholders and the different decision makers again is complex. Then if you are taking any kind of the complex decisions to the respect to that, it makes that okay, whatever the financing system we are adopted, that might be failed. So again, the possibility for the raising of the revenue to be established to customize to the users fees systems, or the congestion chargings, or the congestion pricing systems, or maybe like the allocating of the public space for the different two parts of the cities respective to the different amenities, and that makes corresponding to that what kind of the charges can be levied on that, and what kind of the sensors of the network system and the cameras, and how we are going to implement, and what data to be collected, and how this data to be used, and how we are going to make them tax policies respective to the invested money on this kind of the sensors or like cameras. So ultimately, sometimes it is not only to the what kind of the benefits we are getting each and every component into that. So then we are also trying to look at that what is the socio-economic development of the city corresponding to the implemented projects respective to the smart city. Then we have the different strategies for the funding of the smart cities, like the financial supports from the government, and we have the like the central allocation, then the viability gap funding systems, and the national investment and the infrastructure funding systems we have. Then we have the debt corresponding to the PPP model, that is the borrowing from the multilateral and the bilateral agencies, and the municipal bonds, and the debt optimization bonds respective to the, and the flexible PPP models, and the infra debt funds. Then we have the land monetizations, that is the kind of land commercial residential real estate related funds, and the increasing of the floor area ratios, and corresponding to the increasing of the floor area ratio, then the taxations corresponding to that may be collecting from that even. So these are the ways generally we have the funding strategies, like we have the tap fees, then we have the charges respective to the sale or the registrations of the properties, and the green taxation policies, then we have the urban taxation policies, even we have the new technic vehicle or new technological vehicle taxation policies we have. So all together, these are the some of the funding opportunities we have respective to your smart city generally. So let's start with the financial support from the government, the central government allocation. So that is the cabinet allocated like the almost a 48k crores respect to the smart city projects. So it is funding of the almost 100 crores per year for the each and every 5 years respective to the start of the implementation time. So again, the initial investment will be like the 5,000 crores for the selected cities of the like the preparation of the city development plans. So this is the initial budget plan allocation for the smart cities actually for the various pillars of the smart city. It is not only for the smart transportation even alone. So then we have the allocation of the funds provided by the center. So that is 60% for the infrastructure and 10% for the e-governance systems. The remaining, whatever the budget will be required, that will be shared by the state government generally. So each state will form a special purpose vehicle for the smart city financing system. So that means whatever the fund, the gap is there, that is going to fill by the state governments in general. So then we have the viability gap funding system. So the VGF up to the 90% of the reduction of the project cost from the cities in the hilly areas, and the 40% reduction to the cost for the plain, like the plain terrain. So there is a way the viability gap funding. So the most allocations taken for the hilly regions as compared to the plain regions by the government actually. Then we have the National Investment and Infrastructure Funds. So this NIF are the one of the major source of the funding system for the smart city infrastructure generally. What actually we have seen, what are the different cities they have come up with respect to the smart city point of view. Like there are different types of the borrowing from the multilateral or the bilateral agencies even. So that is the borrowing can be secured from the multilateral agencies such as the ADB, that is Asian Development Bank's financing of the smart city projects. And even the government has sought for the different types of the ADB or maybe like the other banks even for the funding of these projects. Again, we have the municipal bonds. 10% of the funding requirement can be raised through the municipal bonds. The like civic bonds respect to the US or like US, almost the US has raised the 500 billions through these kind of the municipal bonds. And the pooled municipal debt obligations, the PMDO facility, this is the provisions which initially set up in 2006 can be leveraged of the funding from the smart city projects. So then there is a corpus fund is also involved into that. So this corpus fund is also impacting with respect to the implementation of the some of the projects or infrastructure related projects of the smart city even. Then we have the flexible PPP models also are there. So that is funding from the private sectors is necessary to meet the overall funding requirements. Then we have the infra debt funds, that is the IDFs can be directed to the investment of the municipal bonds by defining of these eligible investments and the refinancing of the debt taken for the different types of the construction activities and the additional funds of the financing of the operations respective to the smart city. So like you have invested into the implementation of the cameras, then what kind of the maintenance will be required, that can be IDFs can be refinanced respective to the maintenance and the operational system. So then we have the land monetizations, like it may be like the brownfield projects. So this fund, the fund can be through the sale of the lands most probably. So this land may be like the commercial purpose or the residential purpose for the real estate even. The funds can be also raised by increasing of the floor area ratios, so that we generally treated or corresponding to the land monetizations. Like we have the user charges. So then we have the user fees allows the cities to impose fees to cover the different costs associated with respect to that. So mostly whatever the fund they are implementing or the fund financing to the project, so mostly it is expecting that the 80% cannot be leaved off completely. Only the 50 or 20% is taken out from the government side. The remaining 80% is always is corresponding to the socio-economic development of the corresponding to city or the public point of view. Even that some amount of that actually they are trying to cover with respect to the user charges and the tap fees and other taxations generally. So these are the different types of the taxation policies we generally have. So let's understand with respect to some of the examples of the financing solutions of the different countries, what they have adopted. So before moving on to that, you have any questions on these slides? There are several terminologies are very new probably. So that might be the kind of if you have any kind of misunderstanding or if any things are not understood completely, please raise. So or please ask me, then we will stop here, then we'll discuss again. So if you don't have any questions, then we start with respect to the global examples of the financing solutions. Like if you look at the California respect to the US, so the financing instrument they adopted as the municipal bonds. So it is intended that, so there are different types of the benefits are expected. In 2006, the state of the California is estimated that it will almost say 30% of the money it will be taken out in the next 20 years corresponding to this making of the municipal bonds or like the selling of these municipal bonds even. So there are the financial strategy respective to that. The two-phase 20 years investment plan was proposed. The first year phase involved the issue of the different municipal bonds to the public actually, or maybe like the different stakeholders, not even public directly. So then what is the use and impact with that? So to meet the funding requirements, that is the state voters passed almost a 37.3 billions of the bond packages. So the transportation sector itself, it is receiving a 19.9 billions of the allocation out of this, whatever $37.3 are there of the billions. So these funds went for the congestion reduction, then the highway local road improvement, and the transit improvement, air quality improvement, safety, addressing of the safety and security. So these are the different types of the user benefits can be expected from the project generally. So any questions to be thought process on this slide? Hello? Am I audible?
Yes, yes.
Okay, then we'll move on to the next country, like what they have done. So Toronto, they made the financing instrument as the user fees actually. So what actually they are expecting, the user fees can be leveraged with respect to the securing of the financing, some extent of the project of the finance system, and to fund for the smart city incentives, initiatives of the project actually, or maybe like any kind of the smart city relevance of the infrastructure relevant to that. The user fees allows the cities to impose the fees to cover the cost associated with the funding services and enhancement to the increase the quality of the life and cover the administrative and the regulatory process. So mostly there are, let us assume you need a kind of 100 crores, out of which we can't completely allocate or kind of collecting a fees 100 crores from the users itself. So there is some amount of the fund to be collected. The cost associated with respect to the maybe increasing of the quality of the life or covering of the administrative and the regulatory process alone. So that maybe hardly maybe 10 to 20 crores, not more than that. The remaining 80 crores will be funded, or the raising of the fund will be the different process. Actually. That is the mechanism of the fund. Respective to the whole project will be involved the different methods or the strategies. So what impacts it makes actually in order to address that, so total 500 millions of the deficit money and corresponding to the municipalities in Toronto introduced the levy of users fees and set up the city services such as the $50 for the recreation programs and additional 50 cents for paying of the parking online and the property taxation account. Like these are the kind of the user fees they have started collecting on that, because it is targeting of the next 20 years of the project. So next 20 years they are going to collecting of the user fees on these aspects. So then what are the money they have collected, they used to make the enhancement of the city infrastructure, because again what are the money they have collected, again that money is going to be implementing or like kind using corresponding to the improvement of the infrastructure or city infrastructure. Like if you look at the Colorado in the South Carolina of the US, so again the financing instrument they have used the tap fees. So then the primary use of the tap fees is to cover the cost of the time, whatever the cost is associated with respect to the water meters, because the project total is already implemented, only the water meter cost has to be collected. So then that's the reason the tap fees they have started in terms of the collecting from the users. So then it is also expected that all the residential, the unit pays with respect to the tap fees of the almost a $4,000 for the 1,000 square foot home of the additional $2 per the square foot of the tacked on after that. So if you beyond the any 3,000 square foot home, if you are considering, so then there is additional charge will be incurred into that actually. So these charges are used to fund the capital improvements and the recover of the cost integrating the new development into the existing infrastructure respective to the water lines at the water line tap. So these are the different methods we have. So then we need to understand actually, okay, what is the way we need to address these issues respective to the financing methods, and corresponding to that, what is the economic benefit and how we are going to evaluate the project. So that makes that there is a economic evaluations of each and every project will be important. So it is the kind of the comparative analysis of the alternates what we have corresponding to the course of actions and corresponding to that cost associated and the consequences respective to the finance mechanisms actually. So then finally the policy decisioner or the decision maker will be going to look at that whether this project can be funded or not to be funded. So that's the way the economic evaluation considers the assessment of the all the alternatives comparatively and their effects on the economic terms, which is often the greatest interest of the fund allocators. So like if I want to allocate a fund, then I have the 4 alternatives, and out of these 4 alternatives, which is the best alternative for me? And apart from that, sometimes this economic evaluation will also compare between the projects also sometimes, but very few cases between the project, because sometimes some of the projects cannot be directly compared. Like if I have the bicycle infrastructure planning, then I have the like there is another project improvement of the road in terms of the winding of the road system, or in terms of the coordinator signal systems. Sometimes some of these projects cannot be directly compared, but still if you want to look at that the benefits are equal, then we can make them to compare. So this is the way the economic evaluation considerations of the assessment of the different alternatives to be taken care. So let's understand the economic evaluations of the transport plans generally. So to know whether the plan is under consideration, is worthwhile to invest, and to rank the schemes of competing of the all the projects together corresponding to the resources available, and to compare the mutually exclusive schemes what we have actually, and select the most economic one. The exclusive schemes, like I have the option of the improvement of the road, and I have the option improvement with respect to the moderated technology, and I have the option the improvement operated and right now itself, instead of waiting for the next 5-10 years. Then what is the exclusive scheme we have corresponding to the exclusive scheme? What are the benefits, the economic benefits we are getting? Then based on that we can prioritize the project generally. So then we have the systematic evaluation and identifying of the best alternative over the period of the time, because sometimes some of the projects may give the very good benefits at the beginning of the years, but later on there is no benefit coming out from the projects actually. Like we have the preparation of the highway plans at the national and the regional and the local levels. So then based on these plan preparations, then we need to identify what are the projects we have and how these projects to be funded. So these are some of the very basic concepts we have in the economic evaluations of the project. So the project should be looked at the national view, not at the state level or the not at the urban or like the local levels. The difference between the economic evaluation and the financial evaluation, mostly the economic evaluation is the strategic point of view. If you are implementing this project, what is the socio-economic developments of the project? Then the financial, whether how much I need to fund and when I need to fund, what is the source of the fund. So this is the way generally the financial analysis will be there. Of course, we are going to make it more detailed way of comparing between these economic evaluations and the financial evaluation. And the analysis of the study, whatever the project you are doing for the future, not for the present alone, or the very short time, and all the possible alternatives to be considered in the economic evaluation process. If any alternative is missed up, that makes that okay, there is a economically the project might not be viable, some corresponding to the whatever you left out alternatives are there. And the cost benefit components of the equal magnitude has to be compared, and we need to look at that what is the marginal differences, which means that the marginal differences, like I have the, if I'm taking a project respective to the implement of the like the 2-lane updated or like the upgrading of the project. So then instead of that, what I'm doing actually, okay, there is a stretch of the road, so either I can go for the implement of the 2-lane, maybe like 2-lane either side of the road. So then I need to make that there is upgradation of the 2 lanes. So instead of that, I can go directly making a 4-lane divided roadway, having the improvement of the shoulders and everything like that. So then what is the marginal difference in terms of the economic point of view or economic point of view corresponding to the cost involved into these two projects has to be compared. And this marginal difference makes that, okay, what is the way the improvement of the project to be considered. So that's the way actually we need to make that. So we need to look at all the way when you're doing economic evaluation, that should be taken with respect to the consideration or maybe like corresponding to that. So what is the marginal difference of each and every project we are getting in terms of the economic as well as the financial to be identified, and all the consequences to be also identified to be understand thoroughly. and the analysis period should be extend beyond the period of the reliable forecasts actually. So then we need to also look at that all the future cash flows relevant to the project. So then we have the economic analysis is carried out to determine the most realistic solution from among the different alternatives. So then we need to start these alternatives, start from the do nothing case. There is no improvement of the project, and corresponding to there is improvement of the project, the highest improvement actually. The results will enable that to determine whether each of the alternative is worthwhile at all, and you can rank the alternative, compare one alternative versus the other alternative, then you can compare and you make the ranking of the alternatives. So then apart from the carrying out of the analysis of each of the alternatives, so then there is a do nothing alternative, then there is a kind of the each kind of marginal improvement or incremental analysis corresponding to the alternative. So that need to be identified and need to be compared and to be ranked. So let us consider a two-lane road which needs to be pavement strengthening. So that is the way small example I'm going to take up. So which is there in your SP30. So that we are going to again discuss it during the afternoon session. So traffic forecast maybe indicate that the carriageway needs the widening to the 4-lane divided carriageway as well in the next few years. That is the 2-lane to the 4-lane. That is the highest category. And if you're not going to attempt anything, and that is your do nothing case with respect to the 2-lane alone. Then the alternative 1 will be the do nothing case, and the alternative 2 is the strengthening with respect to the 2-lane pavement, and the alternative 3 can be taken strengthening the 2-lane pavement now and the widening the carriageway to 4 lanes when it is due course of the time, and the alternative 4 can be taken as strengthening of the 2-lane pavement now and widening of the carriageway of the 4 lanes right now itself, instead of waiting for the next 5-10 years. So these are the 4 alternatives we have. Now the question will come, which alternative is best for us? So any thought process or any idea how to deal this kind of problem? So that's what actually the economic evaluation we are expecting. Hello?
Yes, sir.
Any discussion need to be done? Okay, so let's start that how this marginal, hello, yes.
Sir, can we do the topographic survey in that case? Since we know, in this case, yeah, in first study we proposed 2-lane, that will be no any industrial area will be there. After proposing 4-lane, there will be some industrial area or any industrial development coming in the future. That's why we're providing the expansion or the widening the road.
Yeah,
Or
that's
also the economical point of view, we are considering that part.
yeah, that's true. Actually, we generally have, because this is already existing 2-lane, maybe like the undivided roadway. So we have the profile of the existing roadway. Then when you're trying to make a widening in the due course of the time, so then we know that we need to have the land acquire process. If you are making strengthening of the pavement and acquiring of the land after a course of the time, so that makes that there is maybe chances of increasing of the project cost. There might be chances. Instead of that, you do making a acquiring of the land now itself, and you can strengthening of the existing payment, then you can go for the directly widening of the payment. So then there is a different of the cost is there, because so the profiling is already existing is available. So then sometimes if the road currently is going along with the towns or some of the villages, sometimes we need to have some kind of diversions of the lines. Then in that case, it is very important that the profiling or like kind of the understanding of the alignment system respective to your 4-lane from the 2-lane. So that makes that the alternative 4 makes more and more cost compared to the alternative 3. But if you are going to do in the next 10 years, so acquiring of the land at the 10 after 10 years maybe again costing again. So that's the reason we need to have looking at this balancing way of understanding of this alternative 3 versus the alternative 4. So generally, the analyst must carry out the incremental analysis in terms of the benefits as well as the cost together. So we need to start the analysis one, compare the alternative 2 versus the 1, and the 3 versus the 2, and 4 versus the 3. Because once you have done, then alternative 1 versus the 4 obviously have the highest difference in the cost as well as the benefits. So only the problem always with respect to the 3 versus the 4, even some extent of the 2 versus the 3. But the 3 versus the 4 is the more complex and the complicated way of understanding of what are the economic benefits we are getting from the project. So then these results will give completely idea what is the marginal incremental value of your economic benefit corresponding to the financial implications of the project. So then that is the way the basic principle of the economic evaluation will come. So it is the kind of method of economic evaluation to measure that what is the cost of the project and determine that what benefits out of this project actually. So the principle is very simple, but actually the applications is not that easy to understand it. Sometimes when you are looking at the economic evaluation of your project is always respective to the socio-economic development of the project. But the cost incurred respected to the financing mechanism and the complexity of the financing mechanism is not that easy to understand it. Is it really worthwhile to put that much amount of the cost? The most difficult part of the economic evaluation of your transport plan as a project is the identification and the quantifications of the impacts in terms of the benefits out of the project and how these benefits will be dominating respective to your cost. So there are several costs incurred into that. That is the capital cost, that is the initial construction cost we have. In the cost of the delay to the vehicles during the period of the construction. Suppose if you are making the road into the highway, maybe like kind of the urban areas, then most probably you have the more number of vehicles are traveling already into that route. So then there is a kind of delay incurred in respect to those vehicles. Like if you look at some of the projects which are there, sometimes the project will be get delayed, even though project is get delayed. So then whatever the road condition is there, that may be worse and worse day, year on year, a day on day. So respective to that, the travel time might increases to the users. Then there is a more and more cost incurred into the project. So then we have the maintenance cost. So then the capital cost of providing of the transport facility should be estimated accurately to understand of the what is the capital cost, what is the cost of the delay of the vehicles, what is the maintenance cost together. And the cost of traffic control and adding of the lighting installations and the administrations respective to the existing case of the vehicles is very, very complex process. So when a large program, the constructions of the transport facilities are there, so it is very inevitable to understand what is the deal of corresponding to the operations of the vehicles respective to your ongoing or maybe like selected project. Then there is a significant delay will be caused to the traffic, and they correspond to the maintenance cost of the whatever the kind of project are corresponding to the implementing project. So then we need to look at that what are the new schemes respective to the existing transport networks in the determining of the maintenance cost and corresponding to that how these delay cost will be addressed. So like let us assume, say a new proposal maybe reduce a good amount of the traffic from an existing facility. Then the results may be less expenditure on maintenance of the old facility, and it is also ensuring that the future maintenance cost correspond to the discounted to the year in which the calculations are being made. So in simple understanding of this point, we can see that okay, you have the 4-lane divided roadway, let us assume, and you are trying to understand that okay, this project has to be strengthened by making of the new pavement condition of this road. So then that may increases that there is a more and more vehicles are attracted. So the attracted more and more vehicles impacting the maintenance and everything. But what happens actually, so there is a kind of the diverted traffic is also expected if you are not maintaining the road. So let us assume at present in 2025 you are not maintaining a road, then you are expected this road can be extended up to 2030 in the same case. Then most of the traffic is already diverted by 2030 because this route is already worse. So we understood that if you are traveling on this route, it is not that way or it is not good for me in terms of the travel time or delays and all. Or the speed might be reduced like anything. So then after implementing at 2030, making of strengthening of this road, maybe you are attracting the people because it is already a diverted traffic. So then what is the maintenance cost respective to that? The imposing of the kind of toll or maybe anything on the vehicles cannot be achieved directly. So this is the kind of problems can be expected with respect to the diverted or like the attracted traffic even. So there are several ways to address. So these kind of the different types of the diverted, attracted, or the what is the present traffic condition of the specific roads even. So the transportation plans are intended to bring the benefits to the road users by providing of the cheaper and more efficient and quicker and safer travel that may be attracting more and more users to that particular route. An evaluation of the benefits is therefore the prime concerns in the economic evaluations in general. So the benefits usually represent with respect to the difference between the cost of operation and the new facility respective to the cost of operation of the old facility. If I know what is the cost of operation in terms of the vehicle operating cost, a specific category of the vehicles after implementation and the before implementation, then if you take the difference of that, that maybe leads to your benefit. So in order to determine these benefits, it is necessary to determine the cost operations. That is, the benefits can be grouped under to the different kinds of the heads. The benefits to the existing traffic, the benefits to the generated traffic, the benefits to the diverted traffic. So benefits to the traffic operating on the other roads that also to be estimated even. In addition to that, it is necessary to consider disbenefits due to the scheme. Maybe because if you have more and more generated or attracted traffics are there, so that may be increasing of the noise, increasing of the vibrations and congestion sometimes, and the other environmental impacts even. So that makes that okay, there is a disbenefits even if you are improving your project. So quantifications of these benefits to the traffic is very important point. So finally, we need to look at that what is the total amount of the benefits corresponding to the traveler by improvement of the road scheme corresponding to your existing versus the improvement. So then this generated traffic pertains to the journeys which are the worthwhile before improvement and after improvement corresponding to the travel time or the speeds. Then they might be having the vehicle operating cost of these users might be reduced. So then there is a transport improvements and it makes more and more attracting of the traffic. At certain time period, this attracted traffic again will be curtails because if more and more traffic is attracted to that particular route, so there is increasing of the journey times and the delays will be increased corresponding to it. So then there are benefits to the diverted by the diverted traffic are allowed for at the full extent of the change of the user cost. Because if we are changing the user cost, vehicle operating cost, then there is a more chances that okay, there are some kind of the diversion of the traffic can be also expected. Apart from that, if you are implementing the toll fees respective to the improvement of the road, so that means again it is the kind of the diverted traffic will be expected. The improvements to a road may cause the reduction in traffic on the other roads, so that maybe like the other categories of the roads may be reduces. That may be chances that reduction of the congestion can be expected, so that benefits also to be estimated generally. So finally, if you look at that, so there is a decision making process involved into that. So it is important to study that how the urban projects become a smarter corresponding to the different managements of the data collection system or the users or the decision makers or the elected representatives or the researchers. So this information or maybe like the smart cities as the integrated way of the data collection system of the ICT or the IoT, and it is play important role in terms of the collected data and the governing system of the cities generally, and that may lead to the data-led the governance in the smart city, and it is affected by the Internet of Things sensors and the big data. And this smart governance is inherently complex because you have the different categories of the data combined together, and you have the multi-context and the multi-level ecosystems of the various stakeholders involved into that makes more and more conflicting interest of the users or the stakeholders even. So that means it may be dynamic and the multiple natures of appears as the key source of the complexity under uncertainty of the decision making process generally. So then we have the different methods of the decision making process generally. We have the multi-criteria decision making process, mathematically programs and artificial intelligence, and the integrated methods respective to the multi-criteria with respect to artificial intelligence like this. So the multi-criteria decision making, so that's the way even if you have done the economic evaluation, financial evaluation of the project, sometimes the decision making of the different projects are very, very important actually. So that decision making process we are trying to understand with respect to the different methods. So that is the multi-criteria decision making process. It is a kind of multi-step process consisting of a set of methods to structure and formalize corresponding to the criteria, and corresponding to the apart from the criteria, you have the different parameters which are there in the criteria. Based on that, you can make a prioritized comparisons. Based on the comparisons, you start making a decisions, understanding that how extent this decision will be, or this project will be feasible to address the problems to the users. So this maybe allows the decision maker to find the best compromise among a set of possibilities by assessing these possibilities simultaneously according to the multiple dimensions or the criteria generally. And each criteria have the some kind of the what you call as the factors involved into that, or indicators generally we call. So each criteria might be having the several indicators, and these indicators are the factors makes that how the complexity of the problem we have generally. And MCDM is considered the steady state method, providing a snapshots of the hotspots based on the historical data, or may like the based on the collected user information, or based on the different decision making process of the users. So this method maybe does not provide a projections. We can't predict that what is going to be happen in the future, respectively, or what are the decisions you made based on the decision making process or the MCDM techniques. It is will give output or the metric corresponding to the criteria what you have selected, corresponding to the indicators what you have chosen respective to the criteria. But we can't predict that what is going to be happen into the future. So then we have the mathematical programs which need to be optimized to make the goal programming. So my goal is to set up that makes the maximize the benefit, and corresponding to the goal programming. So then we need to have the stochastic or like the different kind of optimization methods. Then these methods will try to address that how to maximize the benefits and minimize their cost incurred into the project. So then there are different ways of the data will be needed to maximize these benefits respective to the mathematical programs or problems. Then we have the other methods like the artificial intelligence techniques, like we have the kind of the Bayesian network systems, we have the simulated annealing technology, or like the genetic algorithm technologies, or like the integrated AM genetic algorithm technologies, which makes that the selection process might complicated way of understanding or implementing of the user behavior into that. And these methods are based on the computer aided systems, how the users will understand the behavioral selection process into the computer aided system will be incorporated. So then the actions corresponding to the human driven decisions to be identified or selected. So there is also integrated methods we have respective to these techniques generally. So in the context of the smart city, so that's the way we have the decision making methods we have respective to the different way of the multi-criteria or MCDM techniques. Then we have the linear programming. Then we have integrated kind of optimal mathematical programs respective to the optimizations as well as the decision making together. So then what are the smart city projects we have, like the urban project? The decisions are made on the three main levels, that is the strategical level, tactical level, and the operational level. The strategical level is the one of the important component of the level to understand the decision making process for the entirely the project is feasible or viable or not. So this level is including of the activities for the setting of the long-term goals respective to the what benefits you are getting respective to long-term, and the policy developments and the visions and the values for the respective to the overall development of the city corresponding to your selected level of the selected the long-term goal of the project. But the tactical and the operational levels are the completely different. That is the medium and mid-level generally. So this level refers to the development of the concrete green space related to the agendas of the actors who regularly deal with respect to the programs at the very short durations, respective to that what is the fund need to be allocated. The operational level mostly respected to the maintenance point of view, the operational point of view, the experimental point of view, the implementation of the goals and the execution that, and how the operational level can be made some kind of the benefits to the users. So that is all about the decision making process respect to the users. So the overall, so we started with respect to understanding of the smart city, then what are the data driven technologies we have into the smart city. Then we have understood, and we have also discussed that the economic evaluation process generally, then how the alternatives to be chosen, then how, what are the methods, mechanisms we have respected to the alternatives choosing techniques. Then we have discussed about the different types of the uh, technologies in terms of the decision making process, are like the different methods or techniques what we have in the decision making process. So that is all about my side. If you have any questions, then we will discuss. There is a question. Depending upon the usage and the traffic conditions, also whether the widening is possible or not, and the availability of the funds. Yeah, it is all depends on the what is the land availability at present, and corresponding to the land availability, what kind of the benefit we are expecting, even if we are going the widening of the road at present itself. So that is the one of the important challenge to understand the when you're doing a alternative 3 versus the alternative 4 comparison generally. Any questions you have? Any thought process or any points to be discussed from the present what we have discussed now? At least someone can speak. So any questions or any points to be discussed? Okay. So thank you all. So we'll meet again at the 2:30. So to discuss about the IRCSP 19. So one some examples we are going to discuss with respect to along with the method of economic evaluation. So some of the method of economic evaluations will start first. Then afterwards, then we'll start the some kind of example, like what generally how the toll to be estimated respective to the different project. Maybe like kind of I have one example or case study, so that we are going to discuss in the afternoon session.
Yes, thank you, sir.
So for the getting of certificate, the attendance is mandatory. So because I have to send to the IIT Hyderabad. So if you have more than 90% of attendance, then only we can give the certificate. Okay. Please try to online. So we'll meet at 2:30 again. Thank you. Thank you all.
Thank you, sir.
So we just sent an message in the WhatsApp group, sir. So we'll again remind once again.
I'll be happy to be added to the WhatsApp group as well if you think.
Sure, sir. I will add.
If
If it is okay for you.
we can talk about that later.
Okay.
So I'll just
Yeah, very good afternoon to all of you. Welcome for this third session of the day one. So first off, will take by Vinayak Dixit. So the next 1 hour I will take. So we are going to cover the method of economic evaluation most probably in this session.
Hi, can you hear me?
Yes, sir. Yes.
All right, perfect. Hope you all have had a good lunch, and it's dinner time here. So no, but all good. So hopefully all excited for the next session. So the purpose of the next session is the way I'm going to approach it is put forth. Let me share my screen first. Is I'm going to share
Yes, sir.
an
Visible.
example. Yeah, is it? Can you see it? Yeah.
Yes, sir. Yes.
So I'm going to give an example, right? Like here we'll do a cost benefit analysis of a particular project which we have made up. And what I want us to do, like as we go through it, it's a made up example, but there are going to be steps which are right, but there are assumptions here which we want to, which I think as a group we should discuss. Is it right? Is it wrong? And what might happen? Okay. So that is the intention. So stop me at any point of time during the discussion, and feel free to put in put in notes on the um, on the chat, and instead of me kind of flipping back and forth, if there's a just open up your mic and speak, please, if that's okay. So here's the thing. Here's the project I made up. So that we can go through the steps. And what I'm going to do is I'm going to share a spreadsheet as well, and I'll go through the spreadsheet. So there's a 100-kilometer corridor, and it is a two-lane highway, which becomes a 4-lane. So that means initially there was 1 lane in each direction. Now there are 2 lanes in each direction. The capex. So what a capex is it is the initial cost of building it. The cost to build this is 2,000 crores, and it takes 2 years to build this. So the first year it is going to be 60%. The next year it's going to be 40%. All right. So that is the first assumption. The operations and maintenance is rupees 50 crores per year. So that means every year making sure that it is the road is cleaned, there is the pavement is of the right condition, is rupees 50 crores a year. Any thoughts about this particular assumption, first of all? Any thoughts? See if I'm okay. Yeah. All right. Nothing. Nothing. No thoughts so far. What do you think should happen? What do you think should happen to the operations and maintenance as the years go by? Will it remain? The first year, would you be spending 50 crores a year in operating when it's a new road? Not really. I think if it's a new road, it might be maybe 3 crores just to kind of make sure that if there's an accident, you're repairing it and all. But generally what happens is your operation and maintenance cost goes up as the years increase, right? So like I said, it is important that's what I'm hoping for you all to be thinking about is, are all of these assumptions right? So this is an assumption right here. Let's assume that it is 50 crores per year, but in reality, it's usually going up. Okay. Now, the traffic AADT. So the average annual daily traffic is approximately 20,000 vehicles per day. Okay, with a 40% cars, 40% trucks, 20% buses, at a growth of 5% per year. This is fine. This is what generally comes from the demand forecast. So based on the demand forecast annually, this is what you develop. Now, there is a before and after speeds, right? So before, the cars were traveling at 45 kilometers an hour. Now it's moved to 70 kilometers an hour. It used to be 30. Now it's moved to 55. It used to be 35. It's moved to 60 kilometers an hour. So basically, the speeds have increased. Now, the question is, can we assume that this is actually going to be true for the next 20 years? Not really, right? Usually what happens is, in the first 4-5 years, your speeds are going to be the increase, the benefits you'll observe are what you observe. But then what happens is, the number of vehicles will, as the number of vehicles start increasing, right, the speeds will also start reducing. So we need to be able to develop a model for that as well. Like, what is going to be the speed every year? But for in this case, let us assume that this is what it is. Any questions, any thoughts so far? I mean, trying to. No questions so far. Okay. All right. The next thing. Oh, right. So we have finished this. Then the value of time. So the value of time is rupees 150 per hour. Trucks is 1,200 rupees per hour, and the buses is rupees 500 per hour. The vehicle operations costs are rupees 2 per vehicle kilometer, 0.5 per vehicle kilometer, and rupees 1 per vehicle kilometer. Okay. Then you have safety and emissions. So what is the improvement? And we're going to actually spend a lecture on trying to go through how do we evaluate the economics of crashes. We'll talk about that as well. Crash reduction benefits. Emissions is straightforward. It's you basically look at the health benefits of that, but crashes are a bit more nuanced. So here we have just found, we have based on a previous study, it has been found that it's going to be rupees 20 crores per year. And the emissions reduction is rupees 10 crores per year. And the discounting rate and life is 10%, 20-year evaluation period with a opening at year 2. All right, so this is the underlying case. Now, I have prepared an Excel sheet. All right, and we will go through each one, and I have definitely made some mistakes, and we'll go through, and it'll be great to figure out if any of you have picked up on those mistakes. All right. Okay. So a couple of hints I'll give you where the mistakes are. First of all, remember that the traffic is AADT. The VOC savings are vehicle kilometers. All right. So I'm going to open up the Excel sheet. So this is basically the net benefit. We'll work through that. So as discussed, CapEx is 2,000 crores. OpEx is 50 crores per year. ADT is 20,000 vehicles, which is basically average annual daily traffic. Cars is 40%, trucks is 40%, buses is 20%. The growth of these is 5%, right? The car speed is 45, it becomes 70. Truck speed is 30, it becomes 55. Bus speed is 35, it becomes 60. And then we have value of time. So value of time savings is basically telling you that if I save 1 hour, it is worth 150 rupees of benefits we have realized. If we have saved 1 hour on a truck, it's 1,200 rupees. And for a bus, it is 500 rupees. All right. Again, this is the value of operations. So VOC savings for a car. So what it's saying is basically what VOC captures is the operational cost. So if the roads are better, there'll be less fuel, there'll be more fuel savings, there'll be less wear and tear on the car. So how much is that worth? That is 50 paise per kilometer. For truck, it is 2 rupees per kilometer. For buses, it's 1 rupee per kilometer. And the crash reduction. So all that. Opening in year 2. So year 1, 60%. Year 2, 40%. So let's go through this. Any questions so far? Is it making sense?
Yes, sir.
It's making sense, yeah. So far,
when you are looking for the value of the time or even the vehicle operation cost, so generally it is expected that it may changes respect to the region, like the city to city value of the time specifically.
Yes, correct.
But when the codal provisions are giving, like the IRC SP30, even for the 2019, they have given a maybe like kind of standardized values of the value of the time. The vehicle operating cost also, they have taken the different examples, and even for that, so they have given the different standards of the vehicle operating cost. So in such cases, when you are considering a project which is originating from the X point to the Y point, so which is stated from the state of like Tamil Nadu to the maybe West Bengal, suppose. So then obviously the value of the time respective to these two regions will be different. How this point can be addressed actually when you're doing this analysis?
Okay, so that's a great point. So when we are doing value of time, right? So the value of time is basically associated to a certain household. So when we do the value of time analysis, it is basically at a fundamental economic level. The value of time is basically associated to the loss of opportunity cost. It's the opportunity cost of traveling. So if I was not traveling and was able to do the same work in my home, or what would be that saving? That is the question. Okay. So usually when we are looking at value of time, we look at value of time based on the origin trip, if that makes sense.
Yes, sir. Yes.
Okay. So when somebody is going from let's say Uttar Pradesh to West Bengal, it is based on the origin household. Now, what also happens is, to your point, there is heterogeneity in the value of time within a region. So going back to Manish's example of Bombay, the value of time in Thane is very different to that in Navi Mumbai, very different to that in Ghatkopar, very different to in Marine Drive. So we then do heterogeneity of value of time based on these different groups, or we just take an average value and do an analysis saying that, look, we understand that there's heterogeneity, but we'll take this one value, and this is an assumption which we all agree to for the purposes of our prioritization. Now, once we have all agreed to that, then that's basically what the results will say. So a lot of these choices around these parameters are a matter of agreement to all the stakeholders. And this is where it is, it makes a difference. It makes a difference, and it is related to the policy. So for instance, if I had taken an average value of the value of time for the whole city, I won't be able to do an analysis of equity or fairness. So if I'm getting benefits from a value of travel time savings perspective, then I might be, and the VOT is got a heavy tail, like the distribution where there are a small number of people, but with extremely high value of time because they're very, very wealthy. You have the Reliance guys and all of that there. So they're very, very wealthy. So, but they have moved the average value of time to somewhere to the right, but it's not equal to the mode. And so you are not giving benefits to the people who might really need it, who might be of the lower economic classes. And that is where that choice really makes a difference. But once, like say, the IRC specifies, so here that is an issue as well everywhere. So usually there's a government circular or a government mandate that is provided, and we generally for projects, if they're saying that that's what it is, then that's what we use. But when we are trying to do analysis based on equity or fairness or something like that, then we have to provide a documentation saying that we are going to be not relying on these numbers because this does not capture the performance indicators which we care about. I don't know if I made sense.
Yes, sir, I
Raghu.
got it. Yes.
Yeah.
Yeah, it makes sense.
So that's a great point. So there's a lot of work around that. So you can actually, from a modeling standpoint, you can look at different values of time. Now, so let's look at each year and see what's really happening, right? So I should have. So the first year, the cost is, because only 60% of it is taken care of, the cost is 1,200. So 60% of 2,000 crores is 1,200 crores. The next year it is 800 crores. Okay, the cost. Now, the main thing to remember is we are also looking at it from a net present value perspective, right? So there is a 10% discount rate. So the first year is 1,200, but the second year will be 1,200, 800 divided by 1 plus 10%, that's 1.1 raised to power 1. So it's what you're doing is the $1, which is so $1 today means more than $1 tomorrow, but how much more? And that's what the discount rate is capturing. It basically is a factor you divide by. All right. So this part, so when I look at this discount rate of 10% here, what I do is, if I look at 100 rupees today, and I'm telling you that I'll give you 100 rupees in 2 years, right? So in 2 years, the 100 rupees for me would be worth 100 divided by 1.1 raised to power 2, 1.1 square. In 3 years, it will be 100 divided by 1.1 cube, and so on and so forth. Does that make sense? That's an important concept of discounting.
Sir, can you please repeat it?
Yeah. So what I'll do is I'll write it out. So I'll write it out here. So let's say there's $100 today. Okay. Now, and I'll tell you that I want to give you. So let me give you a choice. Let me give you guys a choice. If I give you $100 today, or $100 in 1 year, which one will you choose?
One day.
Today, right? You'll get it today only, because what is the point of waiting? Now let me make this 105 rupees, $105, or let me make it rupees. 105 rupees in 1 year. Which one will you take? Will you take 100 rupees today or 105 rupees in 1 year?
100 rupees today.
Today. So there is going to be some number which you will say, maybe you will not even take 110, correct?
Yes.
Will you take 110?
No.
It doesn't, maybe not.
Yes, sir.
150, let's make it a little bit more interesting. Will
No.
you take 150 in 1 year?
No.
No. How about 200?
No.
No. How much will you take in 1 year?
1,000.
1,000. Wow, okay. So what is your discounting rate? Let's try to calculate that. So it's basically 100 is equal to 1,000 divided by 1 plus x by 100 raised to the power the amount of time. So the time is 1 year, so that will be this. So you solve for x. What will be x? So x will be roughly, it'll be it'll have to be 10, right? So it'll be 900. So basically x is equal to, this implies x is equal to 900. So you will need a 900%. So your discounting rate is 900% on 100 rupees. Am I making sense? This is what a discount rate means. So the 100 rupees tomorrow is not worth 100 rupees today. 100 rupees tomorrow would mean probably 50 rupees for you today.
Yes, sir. Got it.
Got it? So this is how you do discounting. So now so what I am telling you right now is based on interest rates, and there are a lot of factors that affect this discounting rate which we use. It depends on interest rates, it depends on bond rates, it depends on how much, it depends on fiscal and monetary policies of a country. But what you're doing is basically you say that in 10 years, or let's say in 10 years, how much will this 100 rupees mean? So that'll be 1 plus 10 by 100, because I've got a 10 raised to power 10. So that is equal to 100 divided by 1.1 raised to power 10. That will be what will be equal to. And I can do a quick analysis. Get my calculator out. It's basically equal to 38 rupees roughly. That's basically what it's saying. So that is what discounting is. Clear? So
Yes.
what I'm saying, so this is 1,200, 1,200. So 800 is 800 divided by 1.1. Now, after the second year, the operation and maintenance cost remains the same, 50 crores per year. All right. So what I do is 50 divided by 1.1 raised to power 2. 50. So you'll see all these, these costs, these costs are reducing at net present value. And after 20 years, it only becomes 7.4 crores. So even though you know that you're going to be doing 50, it is worth 7.4 crores because you're discounting it. All right. That's number one. Benefits. Okay, so that's the cost column. And then that's the net present value for the cost. Clear? Any questions?
Not from my side.
Nothing. Okay, good. Then next, benefits. All right. This is where things become a bit interesting, complicated, and I've made errors. All right, so let us see if you're able to pick it up. So what are the benefits? So let's talk about the first benefit. The first benefit is travel time saving. Travel time saving is what? We have a length of 100 kilometers, right? So now today it takes 100 divided by 45. That is the number of hours it would have it takes. But I would, if I'm able to travel at 70 kilometers per hour, it would be 100 divided by 70. So it will take us less time. So the difference in these two, 100 divided by 45 minus 100 divided by 70, right? That's what I've done. So if I look at this, if you look at 100 divided by 45 minus 100 divided by 70 is equal to the travel time savings of the car. That is around 0.8 hours. That's around 48 minutes, or let's say 47 minutes. Closer to 48 minutes, but that is what I'm saving. For buses, it is close to 1.2 hours. So that is 1 hour and 12 minutes, roughly. Okay, so that's what I've done. I've just taken 100 divided by 35 minus 100 divided by 60. That's the bus. Then I've taken the truck. Truck is again roughly around 1.5. So that is 1 hour 30 minutes. And that is 1 divided by 30 minus 100 divided by 30 minus 100 divided by 55. So that's the amount of hours saved. All right. Now we know the total number of cars.
Yes.
The ADT of cars is, oh, so one thing I forgot also. We also know that it is increasing by 5%. So this is 1.05. You multiply that. 1.05. So that's basically what's happening. So every year it's increasing by 5%. So it starts increasing. So you can see that the volumes are increasing. But the travel time savings are remaining the same, even though the volumes have increased. It's an assumption here, but usually what will happen is that the travel time savings will also reduce. So it'll stay constant, and then because there's congestion, it'll start reducing the travel time savings. That's usually what happens. So to get the economics of this, to get the economic value of the travel time savings, what I'm going to do is I'm going to multiply the total cars with the travel time savings of the cars, plus the buses multiplied by the travel time savings of the buses, plus the trucks, number of trucks multiplied by the travel time savings of the trucks. And that's what I've done here. So if I look at this part, this piece is doing that. Can you tell me if there's anything wrong in this first? What is ADT? It is telling you the average annual daily traffic. So there is roughly around 20,000 vehicles per day on average. Correct? So what have I missed? So I'm only calculating the benefits per day, not over the year, right? So far. So I'm telling you that so many cars are coming in a day, and that's the travel time savings. But there are 365 days. Have I lost you all, or am I making sense, or what's happening?
Yes.
All right. So this is one of the most common mistakes that are made. I remember in my undergrad that I lost 10 points for this, but it is such a common mistake people make that. So you really need to multiply that with 365.
Yeah.
Yeah.
So, sorry, sir, I interrupt you.
Okay.
This value that you are getting is ADT, right? That we have multiplied
AADT, average annual daily traffic.
after multiplying 365, it is converted to ADT, right?
ADT. Yeah. So it's not. It's. So I'm getting the average annual T. So I'm getting the annual traffic then.
Okay.
Total annual traffic
Okay. For year.
per year.
Okay.
Yeah. The moment I multiplied with 365.
3 PS. Got it.
So I'll have to. Sorry, just give me 1 second. I'll have to do this properly. It's not accepting. What has happened? N4. Sorry, let me. So I have to multiply this with 365. End of that. Okay. Sorry, just give me 1 second. All right. So this is what the this is what is the. So I'll just go here. So this is basically telling you the travel time savings. Then the next piece is associated to the $B15. It's associated to the operating cost, and that is very simple. Every car, multiply that with the multiply that with this number. But it is, remember that this is INR per kilometer. So I have to actually multiply this with 100. All right. I have to multiply this whole thing with the length, as well as multiply this with 365 as well.
Sorry, before you multiplying that, before we multiply to the length, after that we multiply through cost value, right?
Correct.
Got it.
So if we have to multiply that with the length, and we need to multiply again with 365 because that's the number of, because we're multiplying it with ADT still. Correct?
Yes, sir. Yes.
So that's what we're doing. We'll do that here. Command V. All right. Now we have updated that. That's good. Then the next thing. We also know that the crash reduction saving is 20 crores per year, actually. This is per year. And this is 10 crores per year. So what we do is we just multiply that. So what we'll do is this is 20 crores. So let's take this. So this is 20 crores. So this I've just multiplied it with crores, and that is 10 crores. And then I just divide the whole thing by 1 crores to make the whole value in crores. So that is around. So this is not cost. This is benefit. Is around 1,116 crores is the benefit, which we observe in the first year itself. So the net present value is around 1,000 crores in the third year, and it starts reducing. Okay, so this is pretty much how we end up doing this analysis. So what you can then do is then look at the benefit to minus cost. So it's telling you that first 2 years is going to be negative, and then it ends up becoming positive, goes high, and then it starts reducing down. Any questions? So this is what I've done is I've given you a very complicated model, complicated question, but have kind of gone through some fundamental concepts. The first concept is the concept of discount rate. Okay. The second concept is that of how do you calculate the economic benefits based on value of time. The third concept is what is the economic benefits based on savings, operational cost savings. Then how do you then add that all up across crash reduction, emission reduction, and then do a net benefit. So when you're doing this over a 20-year period, you can actually calculate the cost benefit. Now, if I take the ratio of this two, I'm getting a 5.23 cost benefit ratio.
Got it, sir.
So so I have changed a lot of the numbers from the previous slides. So don't use that, use the solutions there. So I just wanted to go through this. I'll share this with you on in the chat, so you can actually go through this. Any questions so far? This is basically the fundamental starting point of any cost benefit analysis piece. Any questions? Don't know if I'm able to share attachments. Let me see.
Sir,
Yes, Rahul.
sir, I request you, sir, can you please share this Excel sheet? Actually, it
I
is
am
getting
trying to do that.
complicated. Actually,
Yeah,
it
I'm
is
trying
getting complicated.
Yeah, I'm just trying to do that and go through the slides. Go through the Excel sheet, and we can talk about it. We have the next 4 days as well. We can talk about it later today and or tomorrow morning as well. And we can go through it again. But I'm trying to share this. I'll email it to you, Raghu, if it's okay, and then we can
Okay,
share
sir.
it.
Okay, sir, sure. I will share with them.
Perfect. I'll do that. I know that there are several concepts I've put together, but I wanted to just go through it step by step and walk through that. Any questions?
Sir, in case we are considering for annually, can we consider it for monthly basis? So what is the change in case?
Good. You can have a monthly thing as well. What will be the change? The change might be the discount rate would change a bit, because the monthly discount rate you need to if it's a 10% annualized discount rate, what does it mean per month, right? So you need to kind of come to that value, right? And what you will then get is at a month level analysis. So sometimes it really matters, particularly for I'll give you an example. For concessionaires who have borrowed money from banks, or who have borrowed money from big funds, they are paying huge interest rates, probably 7 to 8% or even more sometimes, even like 12%, to their investors. So it really matters every month. When can they break even? So that's when it's really, really useful. But when you're doing a DPR, usually you don't care. You know, when I say you don't care, you're trying to look at you'll only look at the last cost benefit ratio. Manish.
Yes, sir.
And if you have 10 projects, you'll kind of then, based on the cost benefit ratio, if the benefit to cost ratio is whichever has the highest one comes first, then second, then third, then fourth.
Yeah. Prioritize.
Yep.
But it's
Any other questions? Any thoughts?
Sir, regarding this lecture, I want to understand one concept, sir. That is
Yes.
of maximum benefit, sir. What is it term, sir? Maximum benefit.
Maximum benefit. It can be in various contexts. So it really, you always have to say maximum benefit with respect to what. So for instance, somebody might ask you, all right, this is your benefits and costs, but from where are you deriving your maximum benefits? Is it from the travel time saving? Is it from the operational costs? Or is it from the, so that is one aspect of it. So what you can do is you can split it up and look at the percentage. So let's go here. I'm not sharing my screen. Give me 1 second. So it can be, it really matters. So that question is very, how should I put it? Can be interpreted in different ways. So I'll, this one. So you know how there are these 1, 2, 3, and 4 parts to the benefit: travel time savings, operational cost, safety, and emissions. Which one is providing you the maximum benefit? That could be one question. The second question could be, which year are you observing the maximum benefit? It's probably the second year, right? So that could be another question. Which year are you? So the question could mean a lot of stuff. Happy to take. Does that answer your question? It needs to, there has to be something, for me, at least in my interpretation, there has to be an additional adjective to, or an additional qualifier to it. An additional qualifier in terms of maximum benefit from what, in what context. Does that make sense, Rahul?
Yes, sir. Yes, sir.
Yeah.
Thank you.
So whenever somebody says, what is the maximum benefit, ask them with respect to what, in terms, and you can give them options, so that, you know, sometimes the best way, so I'll give you my own experience of working in this space of transport economics. When somebody asks a question, asking a question back is, usually people get, the person who's asking the question, who's generally your client, they get upset because they're like, oh, you're asking a question to a question. So usually what I do is I provide options to my interpretation of the answer question. So like I said, when somebody said maximum benefit, okay, maximum benefit could be this, maximum benefit could be this. I hope that answers your question.
Yes, sir. Thank you.
So that is a very important strategy as well, when having discussions around this, because it's a very transport economics or any kind of appraisal, any infrastructure appraisal or anything, it is based on so many assumptions that the whole idea of this is to actually get everybody to agree on the similar assumptions and say that, look, yes, we agree that that could be an assumption, but it has this problem, but we can take this into account. We take it into account, but it's not really affecting the prioritization. So sometimes it is problematic to get into I would call what is right. When you're making assumptions, there's nothing which is right. It's all based on assumptions, right? Like this is all based on certain level of agreement on assumptions. So we have to kind of create narratives and come to and provide evidence. When I say create narratives, it's not just making up stories, but create narratives based on evidence to convince the stakeholders that this is an appropriate analysis.
Understood, sir.
Yeah.
Thank you, sir.
Thank you. And sometimes the best way is like for me, it has always kind of uh, uh, Raghu has been has watched this happen a few times. Is if there's an IRC guideline, just say that, okay, this is what has been agreed upon based on the IRC guideline. That's why we are using this. Or this is what has been observed in the literature. That's why we are doing this. Do you have an alternative? Then you have to ask them, do you have an alternative? We can take your alternative and put it into the model. But that is a fundamental thing about transport economics or transport appraisal or economic analysis as well. In fact, one of my colleagues, he was involved in a lawsuit. So a lot of these are also like a lot of these appraisals are associated to lawsuits and legal lawsuits, where if something has gone wrong, how much do you need to pay out the people who have been affected, right? So, for instance, one example has been around smoking, right? Because of certain advertisements, it was improperly advertised, and because of that, there have been health effects. So, how much should it cost? And when it gets into legal, every time every assumption is thrown apart, and you have to kind of defend those assumptions and say that this is what it is based. Similarly, for Exxon Valdez, there was a oil spill. So these numbers they happen through a lot of discussion, and people come to an agreement on a certain. But you have to kind of carefully think through that this is an assumption. This is what is based on certain evidence, or if there is no evidence, then you have to go and collect data on value of time, on discount rates. So like the experiment I did, where we found that for $100 there's a 900% discount rate in a year. So that, and the other assumption we have made is that the discount rate is constant, but the discount rate could also be changing over the years. Yeah. Interesting. Any other questions? I wanted to actually talk about one thing about discount rate. So even going back, it just occurred to me, to your question around years versus months, right? So let's take this example. I took my unit as years, right? So 1,000 years. So sorry, 1,000. So what is your discount rate at a year, on a year level? But if I make it months, right? This becomes 100 is equal to 1,000 divided by 1 plus x by 100 raised to power 12. We can actually calculate this. So it's the 12th root of 10. It will be a different number, which you'll get. The monthly discount rate. I'll leave it up to you guys to calculate. I'm using my phone, so it's, and my eyes are not able to get there. Any questions so far? A lot of fun. Good questions. Any other thoughts, questions?
Sir, I have one question, sir.
Yes, ask now.
Sir, while doing crash modeling,
Crash.
Yes.
Can you explain that?
Yes, sir. Before the sir, we have to use different resource allocation methods. Before that, we develop some countermeasures. That's why we develop some crash modeling.
Oh, crash modification factors. So you're talking about
Yes,
crash.
yes.
Yes. I'll be doing an entire lecture on that. Don't worry.
Okay.
But tell me now. Tell your question, so I can accordingly frame my frame the.
Sir, how can we decide countermeasures in the area of the hilly regions? Actually, it is totally curved. So, can we decide it on the basis of sections or intersections or both, sir?
So in crash modification factors, one of the things is you have to use you use uniform sections, right? You use uniform sections. Now those uniform sections can be decided by 2-3 ways. One, in hilly sections, it is based on a particular section having a certain curvature, right? Then a second section could be based on transition of curvature. So where you're moving from you have a positive radius to a negative radius. So you're so that transition is a second section. And those transition points have different properties, right? You're trying to move from a radius of +10 to -5. So you can either go heavy, you can transition in different ways. So you use that as your uniform section. The next one is so that is one piece, that's how I would actually set it up, but it's a research question in itself. How do you define different sections, uniform sections? So your point is around how do you define uniform sections in a hilly region where things are changing every 100 meters. So it's every 100 meters, it has to be defined by its properties.
Okay, sir.
Does that make sense? And then you can change it. I remember very clearly, this was 2008, almost 10 years back, or 10, no, 12 years back, 12, 14 years back. No, not even 14, 17 years back. 2008, we were doing crash modification factors of intersections, at intersections. One of the questions that was coming up with intersections was, when an accident happens, how do we define it, whether it's due to an intersection or not? Right? Because at an intersection, you can be 100 meters away, 200 meters away, 500 meters away, a kilometer away. Now, 1 kilometer away is, you can pretty much say that it is not influenced. 500 meters also, you can say not. But between 200 or even 150 to, what is it? So what usually people do is they do sensitivity analysis based on that. When is it that things are not changing? So things keep, the model fit improves, and then after that it doesn't matter, or things start improving, decreasing. The model fit starts decreasing. So that is another way of actually doing sensitivity analysis. So when you're not sure about how you need to be developing your crash modification factors based on you, or how to define your assumptions, doing sensitivity analysis is an important way of coming to a solution.
Yes, sir. Yes, sir.
Cool. Sounds good. Any other questions, thoughts? So key takeaways: economic benefit. First of all, discounting. How do you actually account for discounting in your net present value? That's number one concept. Benefits can be measured based on travel time savings, operational costs savings, safety, emissions, and there might be others as well, but these are the usual ones, usual culprits to this game. If no more questions, I can hand it over to Raghu, but happy to take more questions. This has been fun.
Sir, one
Yes,
request.
Mani.
Travel time, operating cost, safety, and last one,
Emissions.
Okay.
At least that's what I considered. There might be somebody else who will be like, but because of these roads, there is going to be more agglomeration. There's going to be more logistics cost. There's going to be reduction in logistics costs, right? So you have to then account for logistics costs and other aspects as well. But yeah, but at least in this case, logistics costs can be also based on inventory, like and I'll go through an example for that.
Yes, yeah.
All right.
Thank you, sir. Thank you so much.
Thank you. Thanks, Raghu. I'll stick around. I'll just listen to the next.
Sure, sir. So hopefully my screen is visible to everyone.
Yes, sir.
Yeah. So I'm straight away starting with the IRC 30. So of course it is updated in 2019. So, but the example what I have taken and corresponding to the one project, that is respective to the numbers of the 2019. So that's the reason I have not updated the some of the numbers, because if you go back and look at the SP30 2009, so these numbers will be there respective to the assumptions specifically. I thought of giving before this actually introducing of the some method of economic evaluations. Most probably that session, maybe that half an hour session, will be going to look at tomorrow morning session. So let's start straight away the discussion about the how the economic evaluation of the highway projects will be taken. So generally, if you look at, there are different types of the cost involved into the transportation. So the road user cost is one of the important component actually. So that is the cost of initial construction of the facility and cost of the periodic maintenance and the road user cost, what actually even Professor Vinayak has given just before this session. So then we have the vehicle operating cost, we have the accident cost, we have the travel time cost. So these costs generally to be estimated based on the different factors to be identified or to be factors to be considered. So when we are estimating a specifically when you are talking about the vehicle operating cost, it is all about the conditions of the vehicles, the fuel cost of the vehicle, and the depreciations of the vehicles and the components involved into the vehicles. Like together, there are several factors involved into the estimations of the vehicle operating cost. And apart from that, the speed corresponding to the given stretch or the selected roadway. That is another important component. So like if you see the vehicle, the VOC component alone, the fuel, lubricant, tires, spare parts, and the labor for the maintenance and the repairs and the depreciation all together put. So generally we'll estimate the vehicle operating cost. So then these elements influenced by the variety of the other factors even. So that is corresponding to the conditions of the road, what is the pavement width and what is the surface condition, whether it is the curve or like the non-curve sections, what is the vertical profile of the road sections. Like there are several other factors are also impacting on the VOC. So because the VOC generally get varies respective to the change of the alignment due to the horizontal or maybe like vertical. So because of the change of the alignment, maybe expected the change of the speed. So corresponding to the change of the speed. So there is a acceleration, deceleration parameter of the vehicle get changes, and respective to that, so there is a change of the vehicle operating cost can be expected. So then apart from that, so the vehicle factor also makes impact, like the make and the age. The make is another important factor generally. So like if you see the older and older vehicles might be emitting more amount of the emissions, might be consuming of the more amount of the fuel. So then the speeds is not expected that effect actually. So that's the reason. So the vehicle make as well as the age, so having the different impact on the vehicle operating cost. Then apart from the traffic related factors like the speed and the volume of the traffic, so that may get changes respective to your VOC. Like if you have traveled along the highest traffic conditions to the lowest traffic conditions, and respective to that there is a change of the speed, so that might be impacting on your vehicle operating cost. So then the environmental like altitude, then the rainfall, climatic conditions, gradient, all these factors make some impact on your vehicle operating cost. So this is the just example of the Mumbai Pune Expressway. So like if you see, we are going to discuss how the length of the stretch they have estimated the corresponding to the total estimated cost of the toll. So then if you see the category of the road comes under the expressway, generally if you see there is a kind of the type of the route, most probably that is also defined respective to the category of the road. So like the primary, secondary, tertiary roads, the primary including of the national highways and the expressways generally, and the secondary including of the your state highways, generally the major district roads. So this length of the stretch they have taken as a 72.58, and the number of lanes are included as 4, and the width of the road is 7 into 2. Total the 7 in one direction and the 7 in opposite direction. And the surface type is the bituminous, and the road condition is good. Like we need to get all the kind of the details to understand to estimate this process. And the roughness, that is the 2000 mm per kilometer, and the average rain rise and fall of the 5. And the curvature, generally we need to understand what is the degree of the curvature and how many number of curves we have, and corresponding to the change of the curvature or like kind of number of curves, if it is increases, then the vehicle operating cost is increasing. Then corresponding to that, the total estimated cost respective to the selected stretch of the road is increases. So then we have the intersections, that is also very very important. If you have more and more intersection, that may be increasing the vehicle operating cost even actually. So then according to the 72.58 and respective to the design speed, so maybe like the around 120 kilometers per hour, then the time of the travel, it is can be estimated 1 hour 20 minutes. So like these are the kind of present day of the traffic corresponding to the selected stretch of the time. So generally this traffic is estimated respective to the continuously 24 hours and the 7-day traffic volume corresponding to that. They also estimated what is the peak hour capacity of the selected stretch, like that is the 4300 PCUs per hour in the major direction, and corresponding to the traffic growth rate of the 9%. So then the cars they observed as the 2720 buses 1119, like these are the kind of traffic of the different conditions of the respected day of the selected survey. So to calculate the yearly traffic volume in terms of the PCUs per day, so with a 9% of growth rate, that is from the 2019 to 2038 they have taken. So then the 10% of this daily traffic is considered as the peak hour. So which is observed as, so what is the average daily traffic corresponding to that? What is the change of the hourly volume respective to the peak hours of the day and corresponding to the non-peak hours of the day? Then they have taken as the 10% of this daily traffic as the very like the highest peak hour, like the peak hour volume corresponding to the calculating of the distance related and the time related congestion factor. And both these congestion factors are to be calculated for the rise and the fall condition as well as the roughness case. So that's the reason. So respective to these cases of the rise and fall, or like the respective to the roughness, we have the base cases of the congestion factors. So like the time based congestion factors, we have like the distance based congestion factors that need to be multiplied with respect to the given data, like the given selected the rise and fall, or like the roughness values. So what actually we are doing currently here? So then we are projecting the total volumes from the 2019 to the 2038 respective to the given hourly volume. So with that volume, so then we are considering as the peak hour traffic volume, that is the 10% that is the highest peak hour volume corresponding to the each and every year category. Like we have the car, bus, LCV, heavy commercial vehicle, multi-axle vehicles, two-wheelers corresponding to the year of 2019. So then entire volume of the year is converted into the vehicles, then the PCUs, then these PCUs we are considering as the 10% is the highest volume. That is the peak hour traffic volume, highest hourly volume. Even if you observe that actually the volume what we are expect to get in a peak hour of a day is more or less is closer to the 2458 case. So then volume by capacity ratios are derived. So we know the capacity of a road stretch of the 7-meter width, or like the 4-lane divided roadway. So then we know the capacity, then we know the volumes. Then we are estimating the volume by capacity ratios corresponding to the values. So any questions up to this, or any points to be discussed specifically? Okay. So then we are calculating the congestion factors, that is the distance related congestion factor and the time related congestion factors. So if you go through the like the SP30, the 2009, that is the economic evaluation of the highway power projects. So then we have the table corresponding to the volume by capacity ratios of the what we have the volume by capacity ratio 0.57. So corresponding to that, so we need to find out the of course, if you see there is a congestion factor related to the distance based congestion factors first. So there is a formula 1.038 plus 0.14 into volume by capacity. So then corresponding to the volume by capacity of the 0.57, so we need to understand that what is the factor we need to have. So this factor we generally have the 0.8 actually. So then we need to multiply with respect to 1.178 into the 0.8, then we get the 0.894. So what we are going to do with this 0.894, so we are going to multiply with respect to each case, then we are going to derive a actual the affected values respective to the congested case of the given or like the projected traffic of the given base traffic. So then these calculations we have again factored. So like the distance related or time related congestion factors are separately calculated generally, and we need to apply some kind of correction factor. So then that can be affected with respect to, so whenever the value is less than 1, it may be considered as the 1. So if it is more than 1, so we have the correction factors respective to that actually. So like we have the this is the correction, so the distance based related congestion factor corrected values respective to the distance based correction factors, like whatever we have estimated like 1.147, so like 0.894, which is less than 1, so we are going to consider as the 1. So like that we are going to do corresponding to each case of the car, bus, the LCV, and respective to the each year. What it actually stating that, so we have the different flow of conditions of the vehicles of a given year or a given time period, and it is indicating that okay, there is a vehicle is passing, respective to that vehicle, so how many number of vehicles are actually accommodated, or like the adjacent that vehicle is closing. So then what is the amount of the congestion is creating respective to this vehicle to the other vehicles. So that is the meaning of these congestion factors, what actually they have derived it. So if the vehicles are surrounded by more number of vehicles, which is indicating that there is more congestion respective to the occupancy of the vehicles to the one vehicle to the other vehicle. The same way we have the time related congestion factors, like this is the formula we have. So generally the VC, that is the time related congestion factor, which is derived from the speed flow relation, 92.76 is minus 0.0075 into Q. So where Q is the kind of your volumes, so then that need to be multiplied, so then you will get the 74.33. So Q is the volume of the traffic in pieces per hour in a year, which we have considered. 2448 is the kind of the maximum hourly 10% volume, 2448. So this volume we have taken to estimate a time-related congestion factor. So any questions till this point? Why we need to have the two different congestion factors? Why it is important to have time-related congestion factor? Why we have the distance-related congestion factor? Any thought process on that? If you ask some questions, then it will be interesting. Otherwise, it will be boring for you.
Sir, maybe there will be the concept of peak hour.
Okay, very good. So there is a peak hour concept. Okay. Apart from that, any other thought process on that?
Answer the number of lanes.
Yeah, okay,
Maybe.
number of lanes. So let's try to understand the distance related congestion factor, how it is derived actually. So it is derived with respect to the volume by capacity ratios. But the time related congestion factor, it is derived with respect to the some kind of speed they have given. So corresponding to the maybe with respect to the speed flow relations. So based on the given corresponding to the given stretch of the point of time. So what is the variations of the speed? Let us assume this is the stretch of the speed I am taking. So then I find out that so there is a kind of the speeds are very high, maybe like the 100 km/h they are traveling. So most probably if you find out or if you estimate a speed of a vehicle of any category or any type or any point of the time of this section is traveling with respect to the 100 km/h. But at this point, if I'm looking that the speed is not actually that easy to maneuver of this kind of curve or maybe like any other kind of aspects related to the specific location of the environmental factors or maybe any other case, maybe gradient or maybe like the rise and fall or like the kind of roughness of the section of anything probably. So that means what we are expecting the speeds might be maybe varies respective to the section to section. At the same time, the volume by capacities, if I'm taking the capacity might be the volumes might be reaching to the very closer to the closer capacity at these blocker sections actually. So which means that when I'm taking a volumes corresponding to the densities or maybe like the number of vehicles I'm counting, so that might be reaching so very closer to the capacity side. So that's the reason. So it is not easy to understand to or maybe like the relevant or rely on the only one factor of the speed. Instead of that, so it is better to have corresponding to the different distances, what is the kind of variations of your congestion factors. So it is also factoring of the different other kind of contributing factors on that. Even actually it is not only the rise and fall, it is not only the number of curves or like the junctions or maybe even if you have any kind of potholes that makes the change of the speed as well as the volume by capacity ratios will get changed. So that makes sense to understand that okay, there should be have the two different types of the factors related to the congestion that is relevant to the distance as well as the time related factors. The time is basically the given stretch of point of the time. What is the speed that the vehicles which are actually passing at that particular section. So then there is a higher and higher speeds expected. Of course, it is also depending on the surrounded by the total number of vehicles. That's the reason. So they derived with respect to the speed flow relations as the volume. So now what we are going to estimate here, the congestion factor we are going to drawn from the what factors we have seen, that is the intercept of the above equations respected to the average speeds of the vehicles like the cars. If I'm taking as a standard vehicle like passenger car unit, passenger car corresponding to the car. So then whatever the speed you are getting 92.76 divided by 74.3 the average speed of the vehicle as car. So then I will get the congestion factor respective to the different categories of the vehicles. So then what we have to do, the value of the congestion factor logically to be limited to the one if it is beyond the one actually. So and a maximum of the two. So that means now we need to find out whatever the factoring value we have according to the point 8. So again, the question will comes, why we need to multiply again with the 0.8 alone? So why can't it is 0.9 or like the any other numbers mostly? So mostly even if you look at the distance related congestion factor, so they are multiplied with respect to the 0.8 after estimating the cumulative values respective to the distance related factor. So any thought process on that, why they are multiplying with the 0.8 here? Or maybe generally we call as the correcting of the congestion factor with respect to the distance as well as time. So if you see, actually most of the time, if I'm taking a peak hours corresponding to our traffic volume, so for the 24 hours time, so it is expecting that there is 80% of the time the vehicles are occupied respective to the given stretch of the road. So mostly there is a kind of two peaks we may expect it easily, that is the congested case respective to if you are expecting that this volume, what we have, this volume is exceeding the capacity of the road, which means that most of the time, so there are two times only the volumes are exceeded, but the remaining two, like if I'm taking this block as the 2 hours, and the another block is the 2 hours, the 4 hours, so 4 hour divided by 24 hours if I'm taking, so remaining almost here like the 20 hours, it is not expected as the completely blocked, or may like the highly congested case are reaching to the capacity case, but 80% of the time it is satisfying what we have designed it actually. So that's the reason. So we are multiplying a factor of the 0.8. So then if you multiply 1.248, what you have estimated as a congestion factor related to the time, 1.248 multiplied with respect to this 0.8, then you will get the 0.9. So in the case of the congestion factor, whenever the values are less than 1, it may be considered as 1. So corresponding to that, so what we have to do, so we have the volume by capacity, that is the speed under congested flow case, and the time related congestion factors case, both. So then these are the average speeds of the stretches corresponding to the different categories of the vehicles. Then we are trying to estimate as for each case of the 92.76 divided by 74.33. The same way 92.4676 divided by 57.066, like that we are doing for each and every categories of the vehicles. So then we are estimating that what is the congestion factors related to the time. So that's the way CFD we got, that is a congestion factor related to the distance. So somewhere we have the CFD we got, congestion factor related to the distance. So then we got the total CFD corresponding to the all the related to the your whatever the volumes we have taken, corresponding to the volume by capacity ratios, that is the volume by capacity ratios corresponding to that. The same way we have that congestion factor related to the time, that is the CFT we also estimated. So then corresponding to that, we estimated total congestion factor values. So this distance related and the time related vehicle operating costs are calculated using the economic cost of the data available from the table of these respective to the codal provisions of the SP30 of the 2009 of the NXLD. So then they have given that this is the total uh, vehicle operating cost, like the fuel cost, tire cost, and put together the total cost is the 1.46. So like if you add all cumulative values, then you may get the 1.46. So now what we are trying to do, so whatever the congestion factor we have, that factor we are multiplying with respect to your vehicle operating cost value, that is 1.46. So what we are trying to do now actually with that, okay, we got the 1.46. So what other cost we have, that is the value of the time. So that need to be taken again. So with that, so whatever the vehicle operating cost is there, we need to go through the each categories of the vehicles, what is the vehicle operating value of the time, that need to be again multiplied. So any questions or any points to be discussed specifically at this point? So we have seen the congestion factors estimations respective to the distance, respective to the time. Corresponding to the distance, volume by capacity we have estimated. Corresponding to the time, so we have estimated the by given equation, we multiplied or we have taken respective to the flow. Then we have estimated the speed. Then the average speeds of the stretches of the different traffic conditions. Then we have estimated a kind of projected values of the speeds. Then corresponding to that, we have estimated a time-related congestion factor. So whatever the speeds we have here, so all these speeds are corresponding to the growth rate and corresponding to the simulated condition. So what is the expected speeds at the different case? Any questions? Okay. So now what we are doing, so the time related vehicle operating cost we are estimating. So this is the distance related time, because so there are two important aspects we have. So based on the distance, the consumption of the fuel increases, the tire, the degradation, like in terms of the wear and tear effect will increases, the engine oil, other oil, grease, and all the parts maintenance will be increases respective to the distance traveled by the vehicle. But if you look at the time related vehicle operating cost, so there is a fixed cost, then there is a depreciation, then the passenger cost will be included, and the commodity cost is included. So this passenger cost is corresponding to that what is the cost incurred by the passenger respective to the time, respective to the value of the time, and like that. So then the time related vehicle operating cost respective to the congested case they have taken. So then they, whatever the 3.93 we have, that is multiplied with respect to the congestion factor value. So now what we are doing, so respective to the different categories of the vehicles, respective to the fuel, tire, or engine oil and all. So then this color is indicating respective to the distance related congestion factor, and this color is indicating with respect to the time related congestion factor. But there are different categories of the vehicles, may varies the fuel consumption, may varies the different types of the wear and tear effect of the tire, engine oil, everything will get varies. That's the reason for each category of the vehicles. So these components respective to the vehicle operating cost will varies, then corresponding to that it is estimated. The same way, so the fixed and the depreciation, so then the passenger and the commodity values also will get changes respective to the different categories. So then based on that, then they estimated the total distance related cost as well as the time related cost. So now what actually they have done, so they compared, they added these two values together. Now the total distance related and time related vehicle operating cost per kilometer estimated 1.46 plus 3.93, total 5.39. So then this is the case for the generally we are trying to look at for the car. The same way for the distance and the time related, if you are adding, so like we have the 21.4.73 plus the 17.26. If we add, then you will get for the bus, like that we have all the categories of the vehicles. Then we have to project it for the 2038 for all these cases. Then it is we'll get the total distance travel as well as the time related vehicle operating cost per kilometer. So now we know at the beginning of the discussion, we have seen that what is the total distance between these selected states. So that is almost 72.56 or something. So that value to be multiplied with respect to this total vehicle operating cost. And apart from that, so we have another important component, that is the wholesale price index value. So generally this value will be computed, what is the total amount of the gross value will be get changes respective to the different categories of the consumption, the demand side of the people or the public. So now if you see that, so there are different types of the components involved into the WPI value. So that is the linking factor between the 93 94 to the series. Then we have the WPI with respect to the other categories of the agriculture products and the manufacturing. But manufacturing is mostly highly contributed into the your WPI value. So it is the generally kind of the road use cost would increases with the accordance of the increasing of the vehicle operating cost. That may be impacting with respect to the total wholesale price index value actually. So that's the reason the wholesale price index value to be multiplied with respect to the total change of vehicle operating cost, because the vehicle operating cost may be also impacting respective to the different goods what we actually like dispatching from the origin, different origin to the different destinations generally. And this WPI is also varies respective to the different cases. So that may be respected to the weekly, monthly, the total amount of the goods transported will be different. So that's the reason. So the WPI makes that there is a difference of the value as well as the difference in terms of the corresponding to the product case and corresponding to the time of the day as well as the monthly, the weekly, everything will get changes. And apart from that, it is also impacting that what is the total amount of the production and the consumption of the different regions. That is also makes the impact on your WPI. So based on that, so what we are trying to do actually, so what are the vehicle operating cost we have earlier? So this is the 5.39 something for the different categories of the vehicles. So corresponding to that, so we are multiplying with respect to our WPI value. So now if you see that, so the VOC is multiplied with respect to the WPI. For example, if I'm looking for the car, 5.39 is multiplied with respect to the 1.429. So then you will get the 7.705. So this is the total vehicle operating cost estimated by corrected WPI value. I hope you got the point why we need to multiply the WPI, or any idea or any kind of points to be discussed in that. Hello? Any questions?
Sir, can you please repeat that WPI part? Yeah.
So basically, the WPI, that is the wholesale price index, will be released by the government of India in the monthly basis generally. So when they are releasing the data, so generally it is indicating that there are different commodities are included. That value is impacting based on the what is the total amount of the productions and the supply, and corresponding to that, what is the kind of demands of these goods of the different categories. Mostly the manufacturing sector is the highly contributing into the WPA, because mostly the manufacturing industry having the lot of productions and the lot of consumption side, demand sides. Then there is a kind of incurred of the vehicles transporting of such goods from the one region to the other region. So what I'm trying to do, okay, if we have the more amount of the productions and more amount of the consumption corresponding to the different categories of the goods, so then what would be the operating cost respective to this increasing of the productions or maybe like the demand? So now if I'm considering, so then put together, because I don't want to look at each and every categories of the goods separately. So what I'm trying to look at, so I'm combining all the goods together. Of course, out of all the goods, the agricultural and manufacturing highest contributor, but put together what is the total amount of the supply as well as the kind of the demand in terms of the vehicles respective to the transporting of the goods from one place to other place, and corresponding to that, how the vehicle operating cost will get changes. Specifically when I'm talking about the goods vehicles, and this factor is very, very important. So that's the reason mostly when we are looking for the mobility respective to the highest categories of the roads, the goods vehicles are the highest contributor than the passenger vehicles in general. Does it make sense?
Yes, sir, but the good category will be varies now for
Yeah.
vehicle to vehicle.
Even the goods category vehicles varies from the category, like type of the goods respective to the goods type, but the highest contributor is the your manufacturing system or manufacturing sector together, put together as a manufacturing sector. So 65 to 70 almost as the highest contributor in the WPA value.
Okay, sir. Got it.
That's the reason. So then the vehicle operating cost, they have multiplied with respect to the WPI. So then they corrected the vehicle operating cost respect to the WPI derived. So then these are the values for all the category of the vehicles. But if you see that there is no much impact respect to the two-wheeler actually, that's the reason. So it is not contributing anything in terms of the specifically for the WPA point of view, or even the vehicle operating cost actually. So it is very, very less contributor. But other categories of the vehicles, specifically for the LCV, heavy commercial vehicles, and the multi-axle vehicles, highest contributors into the as the vehicle operating cost respective to the increasing or the multiplied with respect to the WPI values. So then we know the total stretch of the road. So that is our 72.58 kilometers. So now if you multiply with that 72.58 with respect to each categories of the vehicle, so then if you get the value, so then 7.705 what we have multiplied with respect to the 72.58. then you will get the 559.227. So that is in terms of the vehicle operating cost for a total stretch in the year for the car in the rupees 559. So respective to that, each categories of the vehicle to be added. So now it is not enough actually, because if I'm looking for the value of the time when I'm traveling with respect to the car and the value of the time respect to a specific good category or within the same passenger vehicles category, if I'm taking, so there is a different types of the value of the time can be observed or expected. So that's the reason the car, the value of the time is highest. So if you want to travel with the highest mobility with the higher speeds, then expected that the passengers will choose the mode as the car compared to any other categories of the vehicle. Then it is expecting that respective to the primary route, the value of the time is derived for the car is 62.5 rupees per hour. Like the same way for the two-wheeler is 32, then the ordinary bus is 39.5, and the deluxe bus passenger is 43.5. It is respective to the passenger vehicle category. The same way we have the other categories of the vehicles, even for the value of the time, but that is respective to the goods categories actually. What is the so sometimes there are different categories of the goods. There is a permissible good, then there is other categories of the goods, and these category of the goods will be kind maybe get changes their quality. So corresponding to that, we need to make sure that the choice of the mode to transport such kind of the goods will vary actually. So then we have the secondary routes and we have the primary route, which including of the national highways and the expressways, and we have the secondary route corresponding to the state highways and the MDRs. So then we have the different value of the times derived. So then this is the value of the time to be estimated corresponding to the travel time. So what we have derived earlier, 1.33 at the beginning. So then we have the value of the time multiplied with respect to the travel time of the each categories of the vehicle. So then respective to that, so we have the from the 2019 to 38 projected values, then we have to estimate the value of time in the rupees. Then what we are trying to do actually, so then we have the toll, base rate of the toll values. So that is the 0.65 and for the car and the 2.2 for the bus, which is given as per the standard values of the IRCSP 30. So if you take that values, then if you multiply with respect to the distance, then you will get that what is the toll fees for the stretch. So for the car, so that is the given stretch of the per kilometer length basis actually. So that is the 47.2. So the value for the car at the 2019. So if you see, so it is not varying respective to the increasing volumes or maybe respective to the increasing of the year. So that may be the toll fees will be having the derived respective to the standard values, but it may varies respective to the some kind of the growth rate they will keep into the projected values of the base rate of the toll fees generally. So now we need to find out a generalized cost. First of all, what is meant by the generalized cost? So we have the value of the time, then we have the vehicle operating cost is different, then we have the tolls respective to the base, then put together. So we generally estimating a generalized cost value. So that means but very simple way if you want to understand it actually. So like you have transporting a good from the basic field, agricultural field, and to the nearest marketing centers. From that again it is transporting that with respect to the highest categories. So like the from the using of the expressways or maybe like any other categories of the road. So this is the kind of the marketplace from the agricultural field. So then we have the centers like the maybe like the supermarket, something like that, or maybe like the disposal markets actually we call. So then what we are, so when you are transporting from your agriculture field to the nearest marketplace, the mode what we have used, so maybe like the tractors or something like that, it may be different. And the mode what we have used, so and the expressways maybe like the truck, something like that. And again, if you want to transport very local centers, that maybe mode is different, maybe like LCVs. So then each category of the modes having their own value of the times as well as their own value vehicle operating cost. It is the vehicle operating cost from the production side to the your consumption side is not same. So then there is a variation of the production side to the consumption side. The vehicle operating cost is varies respective to the different categories of the vehicles. The value of the time will be varies, and the tolls, it may be like corresponding to the given stretch of the roads, that might be fixed. So what you have the distance, then what you have the base toll, that is fixed. So then if you put all together, added, so then you will get the generalized value of the cost respective to of your public or like the goods which are transported from the origin to the destination point. Does it make sense? Are any questions on this? Any questions or any points to discuss?
No, sir.
Okay. So once you got this value, so then we have the generalized cost in a year. Then the same way what we have seen, it is the just for the year. So we need to multiply with respect to the total amount of the days which are accumulating values respective to the each categories of the traffic. So then we have the total value as the 689. So then that is multiplied with respect to 365 with respect to the total traffic is estimated. Then you will get the 6847.7. So this is the for the only car. The same way we have to multiply with respect to the all the categories of the vehicles respective to the projected entire 2038 case. So now with that, so you will get the total vehicle operating cost value. So when you are adding put together all the values, then you will get the total vehicle operating cost. So now based on this total vehicle operating cost, then we can identify that what is the total amount. It is like the worthwhile to suppose if you want to invest, so or like you have the total vehicle operating for the base case. So let us assume that you have the total vehicle operating cost of the stretch. So whatever you have seen as the base case scenario. So then this is the stretch of the road I'm taking. Let us assume between the Mumbai Pune of the stretch. So like I know the vehicle operating cost for the base case. So I'm talking about the base case, and the vehicle operating cost for the improved case, or maybe like the development after developing or modifying of the stretch for the 2-lane or 4-lane divided roadway, strengthening of the road or widening of the road, something else. So then we know that what is the change of the vehicle operating cost respective to the change of the condition of your road. So then if this cost is actually as the benefit is higher than the cost as the financial cost is incurred into the project, so then if it is greater than 1 is indicating that this project is viable to implement it. So this is the way generally it will be analyzed, the economic evaluation of the project in general, any projects. So if you have any questions, we will discuss. Otherwise, this is the discussion about the estimations of the vehicle operating cost of a project. So let's see the other case study of the Madurai Kanyakumari. So now if you see that actually, so this is the kind of the route one. Then we have the, there is another route. There are 3 routes are there actually when you are traveling from the Madurai to Kanyakumari. So you are expected to pay, there is a 4 tolls are there. And when you're traveling corresponding to this route, you're expected to pay the 2 tolls. And when you're traveling for this route, it is expected to pay for the 2 tolls. So the general phenomena of the human nature, so we are always trying to like maybe omitting of the sum of the tolls by changing of the routes, whether we don't know what is the vehicle operating cost will be higher by changing of the routes, what we are expected to pay for the as the toll. So that need to be understood, need to be understand. So corresponding to that, so this analysis makes that what is the vehicle operating cost of the different stretch of the roads of the route 1, route 2, route 3. The same way, so first we need to have the idea of the vehicle operating cost respect to the distance based factors and the time related congestion factors like the fuel cost, tire and engine oil and something like, and the fixed depreciation and the other cost, passenger cost. Corresponding to that, we generally have the distance related vehicle operating cost is 1.51 and the time related congestion vehicle operating cost is the 1.33, and the total vehicle operating cost is the 2.84. So what actually this if you recall the actually what we had discussed earlier, so it is all about there are two important factors are impacting. So that is, one is with respect to the what you call the curvature factor, as well as the rise and the fall. So generally we call as the bump values. So are my like what you call roughness indicator. Okay, so this is the roughness factor, meters in per kilometer. Generally the roughness is given for the 0, 5, 10, 15, 20, something like that. So out of which we have to interpolate for the given roughness factor of the 3 meters per kilometer, what is the values we have. So by if you look at the IRC SP30, so the roughness values are there. So then corresponding to the 3 meters per kilometer roughness value, we have estimated that by interpolation of all the cost. Then we have also estimated the distance related and the time related factor. So then the total factor of the vehicle operation cost is estimated. Then the same way we have the average speeds and the distance traveled and the travel times, and corresponding to this is the given data. So the distance traveled from the 245 kilometer of this stretch actually. So this is the corresponding to the 245 kilometer stretch. And the average speeds of the stretch has given, and the travel times corresponding to the stretch of the different categories of the vehicles also given. And the value of the times of the different modes also given, 62.5, 32, 39.5, which are taken from the IRCSP 30. So then the toll rates corresponding to this is the actual toll rates corresponding to the different stretches of the tolls. Like this is the first toll values, the second, third, fourth, corresponding to the different categories of the vehicles. What are the toll rates that has given here actually? So there is no toll price for the two-wheeler. So then these are the toll rates corresponding to all the categories of the vehicles. So then the wholesale price index, so corresponding to that, what we are trying to do. So then we have the value of the times estimated corresponding to the adjusted WPI factor. So then we have the vehicle operation cost estimated corresponding to the WPI factor. So then the toll. So then the same way what we have done in the earlier, the generalized cost is estimated for the different categories of the vehicles. So then if you see that, so corresponding to the generalized cost of the different categories of the vehicles of the route 1, 2, 3. So the route 1 is the 245 kilometer, route 2 264, route 3 is the 253. So then if you see that the generalized cost value, so the route 1 is the 1814, so then the route 3 is the 1550, and the route 2 is the 2133. So now you can understand that, so how this generalized cost can impact, even if you try to change the distance travel, or maybe like trying to avoiding of the congestion, it does not mean that what we are actually trying to pay which will be okay or not. So that is all about the economic evaluation of the project with the two case studies I have given. So if you have any questions, we will discuss, or else we'll, yeah, it is almost 4:20. If you have any questions.
Sir, one request to you. Can you please share this slide with us?
I have already, okay. I will share. Today evening we are going to share the materials.
Yes. Also one request, the Vinayak sirs also.
Yes, sure.
Yes, thank you.
Yeah, we'll share.
Yes.
I will request the Professor Vinayak to share that Excel sheet. Once I got it, then I will share with everyone.
If possible, that sir PPT is also shared, or the last day they will share.
Yeah, we'll share the materials. We already made a kind of PDF of all these slides. Then we are going to share with that. If any slides are missing, then we'll post it accordingly.
Okay, sir. Got it. Thank you.
Any questions or any thought process or any points to be discussed according to the presentation, or maybe any other points are related to the morning to the evening sessions or afternoon session?
No, sir, it is good.
Okay, if you don't have any questions, we'll stop here. So I am requesting everyone to join properly exactly at the time, 10 o'clock tomorrow morning. So then please be online. Okay, even if any net issues are there, please immediately can join after discontinuing or disconnecting of the session. because it is mandatory to have the attendance to get the certificate actually, as per the rules or the policies of the GAN as well as the IIT Hyderabad. So this is our humble request to everyone. So if you don't have any questions, then we will stop here. So I'm going to share very shortly the materials or the PDF what we have created. So tomorrow's session is going to start at 10 o'clock. The first session will be taken by Professor Vinayak Dixit. Then the second session from my side, and again afternoon will proceed by Vinayak. So thank you all. So I'm closing the session. So sir, are you there? Yeah, we will share all the materials, no issue on that. And we will also share the feedback forms at the end of this maybe like workshop, maybe on Thursday, somewhere Thursday or like around Thursday or maybe like the Friday morning session. Most probably Thursday third session. So we are going to share the feedback forms as well as the request respective to the what name to be given in the certificate, like that. So some of these details will be asked. So it is mandatory to fill the feedback forms, as well as there is a feedback form from the GAN, that is IIT Hyderabad side. That form has to be mandatory to fill, as well as the feedback from the NIT Warangal. And we are also going to share a feedback form as a hard copies. You have to fill and you have to make a signature on that, or you need to fill as well as you need to send it to back by making some signatures, digital signature, like that, because we have to submit all these forms to the GAN office actually. So these are the some of the kind of information or the details from my end. So if you don't have any questions, we'll stop here. So thank you all. Thank you for joining. I hope you got some takeaways from these sessions of the morning to evening, like the 3 sessions. So if you are not able to understand any single point, you can stop us, or you can take a note on that and you can ask at any time till we have the 4 more days. Thank you all.
Thank you, sir.